Okay, so with impeccable timing, I managed to get sick this week right before I have to spend 2 days talking, so my voice may give out before the entire allotted time, but I'm going to do my best here. So I feel bad for all the people still sitting in line trying to get their computers registered in here. I hope that we can kind of get all that going a little bit smoother. So a lot of stuff to talk about here. I actually took a little bit of a poll on Twitter a week or two ago about topics, so I'm going to try, I took some notes, and I'm going to try and hit most of those. Actually took some notes for myself here. I haven't graduated to PowerPoint, so I may glance down and kind of keep myself on track with my somewhat virus-addled brain today. But to start with, we'll take a look back at last year. We finally did ship Rage. It was a long time coming, and at the moment-to-moment gameplay, I'm still extremely happy with. I think that the push for the highly responsive, fast-action gaming, I think we did a really good job there. Obviously, there were some flaws with the game, some of which were obvious and easy to look at in retrospect. The lack of a checkpoint save system, the fact that the ending really was not very good on there. And we can look at that and say, well, obviously, it'd be great if we had put a little bit more time in and gotten that working right. But the biggest thing that I want to apologize to all of you here especially is how badly we did on the PC space. There's really no, yeah. I mean, there's no way to argue our way out of it one way or another, and that the release of the PC not working on almost half of our customers because of the driver issues that we had really was inexcusable on our part. I can explain how it happened as sort of optimistic naivete where, I'm all about progress, fixing things, doing the right thing, getting it right, and that led to us, of course, trying to get drivers to a point where they worked the way they were supposed to, but not being smart about the fact that most of the people won't have these drivers, even if things had gone right. And of course, there was a catastrophe at the start there where nobody got the right drivers, the right AMD drivers there. So we're going to do better in the future about that. It was really, really poorly handled. Although it's kind of funny, I came in here expecting to kind of fall on my sword, apologizing about the PC in so many ways and the things that that we need to do better, our long history. But I spent 20 minutes earlier today trying to get the NVIDIA quad buffer stereo drivers working for Doom 3 BFG. And it's like, this is the two-edged sword of the PC marketplace, where we have the incredible awesomeness of being able to do the VR work that we've got to show here, balanced against the platform instability relative to the consoles. And as a developer, working on the consoles does have a lot of advantages there, where just today we're going through the Doom 3 BFG stuff where it's not done yet. We're still fixing things on there. But the console games, of course, we bring them in, we sit down, they pretty much just work the way they're supposed to. The PC, when it's working right, is far, far better. I hope everyone can look at some of these demos side by side, because we have some interesting demonstrations of what factors of 2 in different places gets you. So the numbers that we've got on there right now is that on the 360 and the PS3, if you run normal monoscopic mode, it runs 60 frames per second. If you put it into 3D TV stereo mode, it drops to 60 frames per second per eye, so 30 unique views per second. Now, there was some speculation among people, and I had held out hope that that gave you the apparent smoothness of 60 frames per second, but it just doesn't, at least not for me, although it's possible that some people do process the stereo slightly differently, because I've heard similar arguments about interlaced stereo versus full frame on there. But on the PC, instead of being a 1280 by 720 non-anti-aliased 30 frames per second in stereo, you can run the PC at 1080p or higher. You can run it at 120 hertz if you've got a 120 hertz monitor, or you can run 3D at, ideally, a full 1080p 120 hertz in stereo. Unfortunately, we were having problems getting that running today, so we're stuck with the 1080p split screen mode, which is half the pixels that we should have there. So there's incredible raw power that we could take advantage of, but it's just coupled with these headaches and hassles where we were finding that, turning off this default preset in the control panel, let this work here, but we still couldn't figure out something else. So we've obviously got a ways to go on figuring all that out to make sure that the PC release goes smoothly. So it's been interesting looking back at an 8-year-old game on this. And it's been fun going back to this, where originally this was looked at as kind of a gap filler project where we've got this here, we figured we could make it run on the consoles, and we were shopping it around to outside companies. But we decided that the way our internal resources were sitting at the time, that we really should just do this ourselves, because we should be the best people to do it. We knew if we put it out to another company, we would wind up with a 30 frames per second game, because if we look at the history of the consoles, we had Quake 4, which was a Tech 4-based engine, and it really struggled to hold 30 frames per second on the 360. But we know a whole lot more about the platforms now. We have all the experience that we got going through Rage. And we figured, well, this should be a slam dunk. And before I started the project, I had some vague thought that maybe I'll be able to do the full 60 frames per second stereoscopic, 120 frames per second. But it turned out it's only just barely possible to get to 60 frames per second at all on the consoles. You wouldn't think it, but Doom 3 is actually a lot more aggressive in terms of GPU utilization than Rage is. Rage manages to do everything in pretty much one pass, or one pre-pass and one regular pass, while Doom 3 adds it all up per light on there. And most of the Doom 3 levels are actually considerably more taxing on the systems than Rage is. And we wind up even taxing out the PC in some cases. If you wind up running, multi-mon 2.5K resolution on there, you can suck up pretty much all the power that any GPU combination will throw at you, which in some ways means that it's probably not as good of a use of the power as what we're doing now, but it does have all the trade-offs. And looking back at the game, it's interesting when I go a long ways back to earlier games. Like when I look at the original Doom or Quake running in the original modes, like, my God, these bathroom tile-sized pixels at 320 by 240 resolution, and you're like, this looks horrible. Doom 3, especially when you run it at the higher resolution, still holds up pretty good. When we were showing at E3, we had several people comment that we're not pretending that it's a AAA top-of-the-line title ready to go head-to-head with the very latest releases, but one step down there, the old game still shows pretty well there. And when you do run it on a PC at the much higher resolution, or even at the console, where the game was designed for 640 by 480, pretty much, and when you wind up running it at 720p or 1080p with anti-aliasing and then in stereo, it adds quite a bit to it. So I'm pretty pleased with how all that turned out. One of the things that turned out to be a misstep with the development of that, though, is there was the question about how we would develop it for whether we would start with the original Doom 4 code or if we would start with the Tech 5 code base. And there was a spectacular success with bringing the early Doom versions, the very old versions, to the PS3 by gutting the Tech 5 code base, and that worked out really, really well. One of the things influencing my decision was that there's the whole question about the open source release for Doom 3, where we have a bunch of people that are doing interesting things with the code base, and how does that fit into a Doom 3 BFG release? So I was incentivized hoping that we would go ahead and make it all the way through roughly with the original code base there. But it turned out that by the time we got to the point we are now, we've pulled over a lot of Tech 5 in there in various ancillary things and trying to get all of the console platform-specific stuff in there, as well as lots of the better done code and technologies there. So at this point, I don't know exactly what the situation is going to be for code release and modding. That's still to be determined. We have a number of different possibilities. We might wind up putting in releasing OBJ files for the stuff that we don't want to fully open source. Maybe we can convince everybody that just open sourcing those pieces of Tech 5 that we put into here is reasonable. Obviously, we have to strip out any console-specific stuff, but being able to make a PC build from this would be useful. Specifically, also, I want people to be able to toy around with the VR stuff inside that code base. So I'm hoping we can make something happen, but it's not exactly clear what we're going to wind up with there. It has been, again, interesting to look back at what things changed and what things didn't change over the past 8 years since we did much of the Doom 3 code base. We've got there's a lot of things that surprisingly stayed almost the same. When we looked at our collision detection systems and physics, it was tantalizingly close to what we still have in Tech 5, where the interfaces were reasonably constant. So there was this temptation to say, well, we can get a big speed boost, just pull over all this stuff that's already SIMD optimized, runs in parallel jobs, and all this stuff. But there's all sorts of worries about subtle changes in the gameplay and what effects that may have. But more so when we look at the core sort of rendering architecture through there, we look back at that and say, wow, a lot of things were not done as well as they should be. A lot of things performance-wise or structure-wise, that especially hurts us on the consoles. But a lot of stuff it's nice to know that as a team, those of us that have been with the company through Doom 3 on there, that we actually have gotten a lot better and are developing better software with it. Another thing that's interesting with Doom 3 is it's to the point where we have this really nice modernized code base now that runs on the consoles. It's sort of spiffied up in Tech 4 on there. And I wish that we could kind of deploy this on a bunch of other places where I love platforms. I love looking for the fun things to do on the different ones. And I've been bringing up quietly in a bunch of the meetings, it's like, we could go ahead and make a Vita version, a Wii U version, an iPhone, Android version. All of these would be reasonable platforms for us to take this technology where it wouldn't necessarily be the case for Tech 5. But we do have a very, very busy development schedule, and nothing else is really planned for that. And scheduling all of our development resources is one of the real challenges. After we came off of Rage, there was a very, very strong temptation and desire to go ahead and say, okay, we did some things well, we did some things badly, we know what they are now, we could just go fix them. We can make a Rage 2 that will have all the stuff that was good in Rage, correct all the things that weren't good, make another great game with this. And I was on the side of really wanting to do that, because this idea of iterating on something, fixing the things that we know we broke, not trying to go clean sheet again, make things brand new on there, would have been great. But when it came down to just assessing the limited resources at the company, we did decide that that was not the top priority. We have to have the bulk of the company focused on Doom 4. And Doom 4 is being done in sort of Bethesda mode, where we're still not talking about it. It'll be done when it's done, and we don't want to wind up, letting people read more into it than they should. And that was one of the things that hurt us a little bit with Rage, that we didn't really expect so much, is that as we showed it, year after year, and people kind of read what they wanted to into it, we had a surprisingly large contingent of people that were expecting it to be more like Fallout or Borderlands or something, which was never our intention, but I can look back and see how people thought that might be what the game was about. And that hurt us in the sense that while the gameplay had a long single-player arc for a modern first-person shooter, it certainly was very short compared to somebody that was expecting an RPG experience. So that's another thing that we probably look back as saying, the messaging on Rage probably wasn't all that it should have been on there. But everybody knows what Doom is. Everybody knows what you're supposed to do in there. It's shotguns and demons. And And I hope that when we can start bringing Matt Hooper up here to talk about the project and see what's going into it. In many cases, it's awkward for me being the figurehead for the company because I'm the technical guy. I do tactical gameplay work, but I don't do the big picture stuff on here. And the big picture is more and more important because all of the little things are being done very well in a large number of places. So we do need to have our visionary, creative people that are taking bold steps for us in those directions. And Rage was a big step for it as a company. It didn't get where we would have liked it to go, but surely it was far and away our best effort on the sort of metagame level. And we're going to continue to get better on the tactical gameplay levels. We are continuing to push improvements in the gameplay experience, even faster responsiveness, making that gritty, visceral feel of the game in there, the punch of it. That was another thing that I was pleased to see, in that going back with Doom 3, there's a lot of good stuff there, but Rage definitely has better punch. It's nice to see that the action core that we focused a lot on improved, and will continue to improve that. Another thing that I recognized when we went back looking at Doom 3 visually, and I actually saw this last year before the before the GPL code release. It's funny looking back at something there. I was so proud of the unified lighting model at the time of it's just everything is the same, everything's lit the same, shadowed the same on there. And when I first looked back at Doom for the first time in 6+ years or so on there, and I saw one of the hard shadows kind of sweep across there, I honestly wondered if it was a rendering bug. The complete lack of any ambient lighting in most of the game on there, and just seeing a big black swath slide across something. When I was working on removing the patented stencil shadow stuff on there, I had to double check myself to make sure that it was actually functioning as designed on there. So the difference in the ambient lighting is something that that really was a real stride forward. But I can also see what people look for in the dynamics of it, about being able to have everything running around and toppling. And that was one of the things that we all recognized, that Rage did feel a little stiff, that we didn't have enough things that would move around in the world and that were interactive. We had these gorgeous compositional vistas, but the world was, to some degree, a shell, and not that much of it was interactive. So that is one of our marching orders for going forth and doing better in the next game. Now, across the rest of the studio, we've got Quake Live. While obviously the in-game advertising stuff completely failed twice. We had 2 partners go bankrupt. In the in-game advertising business, that just clearly doesn't work in that space. But the pro memberships are making ends meet on there, and Quake Live's continuing to tick along with a bit of support there. We did make the decision to close up our mobile development, which saddened me a lot, in that I love doing the mobile work, taking that time, spending a month a year or something working on a mobile project. But we had some developers on there that we wanted to bring onto the Doom 4 project, and it was looked at as something that, yes, this is fun, this is fun for the company, and it's entertaining, it makes money, but it's not a grand slam sort of thing on there. And the Bethesda family really is about swinging for the fences. I hope that we do get back to mobile in various ways in the future, but the real aim is blockbuster AAA titles. And for id, that means Doom 4. That means that we get the whole company behind that. After we get Doom 3, the BFG Edition out the door, then essentially everybody will be focused on Doom 4 as a project. And we've got... we still do not have the formula for how to effectively utilize large numbers of people. Everyone struggles with it. We may struggle more than many. We're still figuring out what to do on there, learning lessons as we go. One of the larger ones is that we do need to just maintain some stability in our pipeline on there, that we can't keep changing everything all the time. One of the games that I sometimes play with myself, thought-wise, is thinking back and say, okay, 20 years of development on here, if I could go back, what major technical things would I have done differently? And a couple of them are pushing off some of the aggressive technological things that required major changes in the pipeline. Like, if I look back, and I could do it all over again, I probably would have taken all of the modding goodness out of Quake and done it in a Doom-class engine, gone ahead and had internet capability, persistent servers, modding, QC-type stuff, but not requiring everyone to have the floating point Pentium and the really high-end systems to be able to get that gameplay, and then bring that in later. Clearly, with our games taking 6 years plus to make Rage, you can't do that over and over again. I mean, I have lots of people say, I'd like to play more than one id game a decade. I'd like to ship more than one id game a decade. So we can have, yes, every decade there will be a Doom, but hopefully we can do a little bit better than that. But a lot of that does come down to not doing crazy apple cart upsetting pipeline changes. And the plan had been, it still is in general, that I do think that the next major upset in the pipeline is virtualizing the geometry. It's the obvious next thing to do on here, but we are not directly working on that, at this moment. Whether it is, triangle mesh decomposition that's dynamic, or a sparse voxel lock tree, or some other ray tracing or splatting form, it is clear that there's another good step to be taken there. But one thing that we find reinforced as we do tests is that we can do really good visuals today. We really haven't tapped out the potential of what we've got, even on existing platforms. The platforms keep getting better with constant technology on them. And one test that we did relatively recently is we have multiple resolutions for characters in the current build, and somebody set up a test to go ahead and say, well, let's put in the low poly one and the high poly one here. And it was really disappointing that most people couldn't tell the difference, and some people picked the wrong one. When you go between 8,000 or 10,000 and 50,000 polygons on there, it matters when you're doing a headshot in a cinematic on there and you're looking at a face with 300 bones in it doing everything. But if you're running around in a game, even if you stop time and run around and look at things, we are well past the knee of the curve in terms of what we really deliver on that. Now, it's true that there's a selection bias in any test like that, where if you build an asset towards one level, going up in it is never going to be able to make it look radically better. All you can really do is make it look smoother. And the technologies of normal mapping and other kinds of bump mapping take much of the value out of that. All you're really doing is smoothing the silhouette edges at the expense of 5 times more memory bandwidth and 5 times slower performance. And it's not a hugely wonderful trade. If, however, you were able to author strictly for that higher level, you could make more interesting graphics. But it's still not to the point where you can say, well, it's even further away from the point today where you can say, I'm just going to author for the very highest in platforms. That's just not reality. Games are incredibly expensive to develop, and you have to be able to push towards a broad market. But it's still true that any creative vision that somebody comes up with today, a designer can say, I think this will be the coolest game in the world and involves this and this and this and this. A competent technical team can implement that on today's hardware, with today's sort of engine technology, and it will look pretty darn good. As a graphics geek, I can spend lots of time talking about all of these subtleties. We can talk about all of the issues with why you need gamma correction to be able to have anti-aliasing working right, and why you may want to do forward calculations instead of reverse in screen space. And there's a ton of things that matter a little bit, but I'm extremely conscious that I'm like one of those audiophiles talking about jitter on CD player outputs. It's not really that important, and in many cases, it's not even really there, because modern displays, what most people play their games on, they're not color calibrated. A lot of what people talk about with a lot of the very fine modeling of surfaces and getting the lighting and the gamma correct and getting all the indirect illumination correct, it doesn't actually make that much difference. Well, if somebody's gamma is off by 0.5 or something, and they can often be off by more than that, all of these fancy calculations that you're doing, all of these extra exponentiations and powers and roots, and setting all this up and wider frame buffers, and you've just made a different set of pixels that you do the A/B test on people, and you'll find a bunch of people that think the wrong one looks better anyways. We actually have these arguments between a lot of the artists and programmers over post effects and things like that, where you're just sticking all of these carefully crafted pixels in a blender and pouring food coloring in there. It's depressing sometimes to think about all the effort that goes into lighting them correctly, and then it's like, we'll color balance this and dodge and burn that and field of view it down. And so, as a long-time, almost archetypical graphics geek, some might say that I'm sort of giving up on the prize there, but it's more important for us to be able to make the games faster. And the iteration time is what's killing us on changing the pipeline. It took us years to get the Tech 5 pipeline really stable, really working. And going from, I had demos of the technology, before Doom 3 even shipped. I had some early stuff that I was showing about, look, let's mega texture an enormous terrain, and it eventually made its way into some of the enemy territory stuff there. And then years passed as we went through different ways of authoring content, different ways to build worlds with it, going from GPU acceleration to CPU cluster acceleration, switching everything to ray tracing on the content generation side. running into all the limits on the models, running into terabyte hard drive limits, figuring out how we do all of this. It was a huge undertaking, and it all pretty much works right now. Going ahead and throwing another 2 orders of magnitude difficulty on top of it, there's a big part of me that wants to just say, yeah, we can go do that. It's all possible. I've run the numbers. We can make this happen, but it'll take more years. And the difference between what you get by iterating or making 2 games in that time, I really think is actually more important now. And that was one thing that was fun with Doom 3 on there, where because it's an old code base, everything compiles faster. It's maybe, we took out all the tools, so it's maybe, I don't know, a quarter or less the size of the Tech 5 code base with all that removed. So turnaround times are faster. The designers, because it was the beauty of the Doom 4, or Doom 3, the Tech 4 engine, was that everything was dynamic. It was very, very fast for the designers to make changes. And we did make a pass through all of the levels in Doom 3. Brightening things up, the obvious, one of the huge problems with Doom 3 was the game was just too dark. And some of that was me. My wife brings this up all the time about how I killed the flashlight originally because I didn't want one more dynamic render light in the entire scene because it was going to affect the frame rate too much. Because, thinking back then, we were, limping along on the PCs with that very finely tuned number of lights on there. I'm like, well, you throw the flashlight out there, everything casts a dynamic shadow. It's one more pass over everything. The frame rate will get cut in half, and we just can't do that. The game will be like tense and fun having to switch between your flashlight and your weapon. And it was, the funny thing is that when we said in BFG that, okay, the flashlight's there all the time as an option, you can bring it up with one of the triggers on the controller, we had a bunch of people come out and say, no, you're destroying the ambience of the original game. And there's something to that, to the sort of, masochistic sense of running through the game like that. But the game is a lot more fun when you can see and appreciate what's in there. You can just kind of shine the light in every dark corner, run around and play like that. And the other thing that's interesting is we look back over previous generations of games, and gamers were a lot more hardcore back in the old days. We saw it in Doom 3 when we're looking at how hard the game was in many cases. The ammo stinginess on there, about how carefully you had to go ahead and find every last little thing and aim your shots on there. And we have gone through and more liberally sprinkled ammo through it, which changes the tone of the game a little bit. So it's not so much survival horror, and it's more action-oriented game on there. But it is a lot of fun to just kind of run through and play. And I see that in other games, too, when it was a couple years ago when I finally went back and actually played Super Mario 3 all the way to the end. It's like, damn, this is hard. It's like one of those final ships on there, and I'm like, I've restarted this 20 or 30 times while, the current Super Mario Galaxy, New Super Mario Brothers, wonderful games, all this wonderful design on there, but you just kind of sit back and cruise through it, smile, and say, that was really fun, but not really, so much challenging. And it's interesting to see how the mainstreamizing of gaming has taken that. But undeniably, games are better today. We have fond memories for the old days on there, but the games were limited in a lot of ways, and the design that we see in games today, I'm still very impressed by all the work that's going on in the mobile space, all the new styles of games, new ways of bringing people into the smaller experiences and pulling them through it. And there's lots of excellent stuff. So I never fall into one of the good old days times on there, because things are still, things are great today. Progress is great. We're making lots of excellent changes in direction and everything. So in trying to make the games faster, which has to be our priority going forward, and we've made a lot of mistakes already with Doom 4, and a lot of it's water under the bridge there, but prioritizing things that can help us get the games done faster just has to be where we go, because we just can't do this going 6 more years, whatever, between games. On the software development side, there was an interesting thing at E3, one of the interviews that I gave. I had mentioned something about how, I've been learning a whole lot, and I'm a better programmer now than I was a year ago. And the interviewer expressed actually a lot of surprise at that you'd think that, after 20 years and going through all of this, that you'd have it all figured out by now. But I've actually really have been learning quite a bit about software development, both on the personal craftsman level, but also paying more attention to what it means in the team dynamics side of things. And this is something that I probably avoided really looking at squarely for years, because it's nice to think of myself as, as a scientist engineer sort, dealing in these things that are abstract or provable or objective on there. And in reality, in computer science, just about the only thing that's really science is when you're talking about algorithms, and optimization is an engineering task, but those don't actually occupy that much of the total time spent programming. We have a few programmers that spend a lot of time on optimizing and some of the, selecting the algorithms on there, but 90% of the programmers are doing programming work to make things happen. And when I start really looking at what's going on in all of these, there really is no science and engineering and objectivity to most of these tasks. One of the programmers actually says that he does a lot of monkey programming, where he's just going in and, beating on things and making stuff happen. And, we like to think that we can be, smart engineers about this, that there are objective ways to make good software. But as I've been looking at this more and more, it's been striking to me how much that really isn't the case, where aside from these things that we can measure and reproduce, which is the essence of science, to be able to measure something, reproduce it, make an estimation, and test that. And we get that on optimization and algorithms there, but everything else that we do really has nothing to do with that, and it's about social interactions between the programmers, or even between yourself spread over time. And it's nice to think where, we talk about functional programming and lambda calculus and monads, and this sounds all nice and science-y, but it really doesn't affect what you do in software engineering there. These are all best practices, and these are things that have shown to be helpful in the past, but really are helpful only when people are making certain classes of mistakes. Anything that I could do in a pure functional language, you take your most restrictive, scientific-oriented code base on there. In the end, of course, it all comes down to assembly language, but you could do exactly the same thing in BASIC or any other language that you wanted to. And one of the things that's also fed into that is my older son's starting to learn how to program now, and I actually tossed around the thought of, should I maybe try to have him learn Haskell as a 7-year-old or something? And I decided not to. That I actually don't think I'm a good enough Haskell programmer to want to instruct anybody in anything. But as I start thinking about how somebody learns programming from really ground zero, it was opening my eyes a little bit to how much of what we take for granted in the software engineering community really is just layers of artifice on top of a core fundamental thing. Even when you go back to structured programming, whether it's while loops and for loops and stuff, at the bottom, when I'm sitting about thinking, how do you explain programming? What does a computer do? It's really all the way back to flowcharts. You do this, you do that, if not, you do that. And even trying to explain, well, why do you do a for loop? Or what's this while loop on here? These are all conventions that help software engineering in the large when you're dealing with mistakes that people make. But they're not fundamental about what the computer's doing. All of these are things that are just trying to help people not make mistakes that they're commonly making. And one of the things that's been driven home extremely hard was that programmers are making mistakes all the time and constantly. I talked a lot last year about the work that we've done with static analysis and trying to run all of our code base and get it through squeaky clean with all of these things. And it turns up hundreds and hundreds or even thousands of issues. Now, it's great when you wind up with something that says, oh, clearly this is a bug. You made a mistake here, this is a bug. And you can point that out to everyone, and everyone will agree, okay, well, I won't do that next time. But the problem is, the best of intentions really don't matter. If something can syntactically be entered incorrectly, it eventually will be. And that's one of the reasons why I'm very big on the static analysis. I would like to be able to enable even more restrictive subsets of languages and restrict programmers even more, because we make mistakes constantly. One of the things that's been that I started doing relatively recently is actually doing a daily code review where I look through the check-ins and try and just find something educational to talk about to the team. And I annotate a little bit of code and say, a few times like, well, actually, this is a bug discovered through code review. But a lot of it is just, favor doing it this way because it's going to be clearer, it will cause less problems in other cases. And there were a few people that got some ruffled feathers early on about that with the kind of broadcast nature of it, but I think everybody is appreciating the process on that now. And that's one of those scalability issues where there's clearly no way I can do individual code reviews with everyone all the time. It takes a lot of time to even just scan through what everybody's doing. Being able to point out something that somebody else did and said, well, everybody should pay attention to this, that has some real value in it. And as long as the team is agreeable to that, I think that's been a very positive thing. But what happens in some cases is when you're arguing a point that's saying, like, okay, you should put const on your function parameters or something, that's hard to make an objective call on, where lots of stuff we can say, this indirection is a cache miss. That's going to cost us here. It's objective. You can measure it. There's really no arguing with it. But so many of these other things are sort of style issues where I can say, over the years, I've seen this cause a lot of problems. But a lot of people will just say, well, I've never seen that problem. That's not a problem for me, or I don't make those mistakes. So it has been really good to be able to point out commonly on here, okay, this is the mistake caused by this. But as I've been doing this, more and more and thinking about it, that sense that this isn't science, this is just trying to deal with all of our human frailties on it. And I wish there were better ways to do this. We all want to become better developers. It'll help us make better products, do better jobs at whatever we're doing. But the fact that it's coming down to training dozens of people to do things in a consistent way, knowing that we have programmer turnover as people come and go, new people come in looking at the code base, not understanding all the conventions. And there are clearly better and worse ways of doing things, but it's frustratingly difficult to quantify. And that's something that I'm spending more and more time looking at. And I read like NASA's software engineering laboratory reports, and I can't seem to get any real value out of a lot of those things. The things that have been valuable have been automated things that don't require a human to have some analysis, have some evaluation of it, but just say enforced or not enforced. And I think that's really where things need to go more and more as larger and larger software gets developed. And it is striking the scale of what we're doing now when if you look back at the NASA reports about the scale of the code bases that they do, when they considered large code bases to be things with 300,000 or 400,000 lines of code, and we have far more than that in our game engines now. And it's kind of fun to think that the game engines, things that we're playing games on, have more sophisticated software than certainly the things that launched people to the moon and back and flew the shuttle and ran Skylab, run the space station. All of these massive projects on there are really outdone in complexity by any number of major game engine projects. And the answer, as far as I can tell, really isn't out there. With the NASA-style development process, they can deliver very, very low bug rates, but it's at a very, very low productivity rate. And one of the things that you wind up doing in so many cases is cost-benefit analyses, where you have to say, well, we could be perfect, but then we'll have the wrong product and it'll be too late. Or we can be really fast and loose. We can go ahead and just be sloppy, but we'll get something really cool happening soon. And this is one of those areas where there's clearly right tools for the right job, but what happens is you make something cool and fast, and then you live with it for 4 years, and you suffer over and over with that. And that's something that I don't think that we do the best job at. We know our code is living for, realistically, looking at a decade. I tell people that there's a good chance that whatever you're writing here, if it's not extremely game-specific, may well exist a decade from now, that we'll have hundreds of programmers looking at the code, using it, interacting with it in some way. And that's quite a burden, and I do think that it's just and right to impose pretty severe restrictions on terms of what we'll let pass analysis, what we'll let into it. But there are large-scale issues at the software API design levels and figuring out things there that are still like artistic, that are craftsman-like on there, and I wish that there were more quantifiable things to say about that. And I'm spending a lot of time on this as we go forward, and I think we've got an excellent software development team. One of the things trending back towards rage on there that made me just deeply sad the way it all worked out is we had an extremely reliable shipping code base. We had all of this, we passed all of this analysis stuff. We passed all of these this test cases on there, and to be tripped up by the drivers outside of our control and be regarded as a buggy release on the PC, that really, really hurt. But it was one of those things that makes me look at it and say, well, we can't get the same level of control there, but clearly we need to do a lot better, or we wasted a lot of time doing this to wind up with something at this relatively low level of reliability. So software development is where I wind up spending most of my time. The applicability of this to looking across all of our different platforms, many of the things that people wound up asking about in what do we want to talk about here are all the different platforms that are potentially emerging, what we think about them. I told everyone straight out, I can't say anything about next generation consoles. We have NDAs on stuff, and I can't. It's going to be fun talking about all of this years from now when it's all out in the public and there's and we can go back and talk about, like, everybody knows what's in the 360 and the PS3 now, and nobody really cares when you wind up discussing the relative pros and cons of, different PowerPC versus, cell implementations on there. But there are a lot of interesting platforms, and like I said about the Doom 3 BFG, I'd love to be on more of them because it's fun to go and push things to the different platforms, and there are lots of exciting things. I regret not being able to work on the mobile platforms more. I enjoyed the iPhone development a lot. And unfortunately, we have a couple projects on there. We have an iOS project that's sort of sitting in the can now with all the rest of the Doom Classic stuff, but we just haven't been able to push it through. We're going to hold off until some appropriate time maybe we can do it with the Doom 3 BFG stuff on there, but it's been unfortunate that we can't do any further development on that because it's a lot of fun. We have a lot of people that wind up attracted by the allure of going off and being a small indie development shop for the mobile devices. But what's kind of frightening about that is how fast that market evolved, where it hasn't been that many years since it was somebody randomly throwing something together, makes the big hit, and hits it big and rides that wave off of something on iOS. While now you still have certainly some small operations, but it's pretty big and professional now, and it is hard for a couple people to go off and make a dent in the market now that you have lots of teams of professional developers that are doing innovative, solid quality work backed up by sort of the resources of a larger development team. But it is also true that the margins are obviously a lot smaller there, and you can't from scratch design some massive game targeting there without being a real serious gambler, because it's hard to wind up making $20-30 million. Some companies do, but it's certainly the exception rather than the rule. Other interesting sort of PC-ish platforms, we have the Mac still remains a viable platform for us. The Mac has never required any charity from it. All of those ports have carried their own weight there. They've been viable business platforms. I actually think that the Mac is going to become a little bit more important for us. Interestingly, we have a ton of people that use like MacBooks, laptops at the office, but we don't have any really rabid OS X fanboys at the company that drive us to go ahead and get the native ports out early. But one of my pushes on the greater use of static analysis and verification technologies is I pretty strongly suspect that the Clang LLVM sort of ecosystem that's living on OS X is going to be fertile ground for a whole lot of analysis tools, and we'll wind up benefiting by moving more of our platform continuously onto OS X just for that ability to take advantage of additional tools there. Linux is an issue that's taken a lot more currency with Valve announcing Steam for Linux, and that does change factors. It changes things a bit, but we have we've made 2 forays into the Linux commercial market, most recently with the Quake Live client. And that platform just hasn't carried its weight compared to the Mac on there. It's great that people are enthusiastic about it, but there's just not nearly as many people that are interested in paying for a game on the platform. And that just seems to be the reality. Valve will probably pull a bunch more people there. I know absolutely nothing about any Valve plans for console Steambox stuff on there. I could speculate without violating anything. One thing that also speaks to the favor of Linux and potential open source things is that the integrated graphics parts are getting better and better, and they really are good enough now. Intel's latest integrated graphics parts are good. The drivers still have issues. They're still certainly not going to blow away somebody's top-of-the-line SLI system, but they are completely competent parts that are delivering pretty good performance. And one of the wonderful things is that Intel has been completely supportive of open source driver efforts, that they have chipset docs out there, and they work openly with the community to develop that. And that's pretty wonderful. I mean, anybody that's a graphics guy, if you program to a graphics API, you use D3D or OpenGL, you owe it to yourself at some point to go download the Intel chipset docs, and there's hundreds of pages of them, but you really should read through and see what happens at the hardware level. It's not the same architecture that NVIDIA and AMD have on there, but there's a lot of commonalities there, and you'll grow as a graphics developer to know what happens down at the bit level. And another one of those things that if I had more time, if I could go ahead and clone myself a few times, I would love to be involved in working on optimizing the Intel open source drivers there. So it's enticing, the thought there that you might have a well-supported, completely open platform that you could deliver content through the Steam ecosystem there. It's a tough sell on there, but Valve gets huge kudos for having the vision for what they did with Steam, sticking through all of it. It's funny talking about Doom 3, where we can remember back in the days when they're like, well, should you ship Doom 3 on Steam? Go out there, make a splash. And we're like, you're kidding, right? That made no sense at all at that time. But Valve stuck with it, and they're in a really enviable position from all of that now. So it still seems probably crazy to me that they would be doing anything like that. But it's something that's not technically impossible, but would be really difficult from a market sort of ecosystem standpoint. And related to that, the Ouya stuff, where you've got basically an Android phone that you plug in over an HDMI cable, that seems a pretty long shot to me, and it's, again, technically possible. It's wonderful that these chipsets that you get that are driven by the smartphone market give you quad-core, good GPU graphics, and you can plug a video out on it, and it should be something that you can make cheaper than a good smartphone, because the displays and batteries and all that are a decent chunk of things, and you can make something that just plugs into a TV really cheap, the Raspberry Pi sorts of things and all that. And it's a platform. It's interesting. You could write games for it. It would be reasonably pleasant to program for, although in general, from a programmer standpoint for games, it's nicer to program straight to Linux than it is to program to Android, where you still have to kind of shim things through through a Java layer there. So possible, but it's a little hard to see what the value proposition to developers for doing that is, where there are plenty of consoles now. Saying that the value proposition is, well, indie developers can get on there where it's harder to get onto the consoles. That's something, but that's probably not something that a business will run on. Now, the best bet probably still is something like on-live cloud game streaming, where that's another thing. Every time I see Gabe Newell, I keep mentioning, Valve really should be kind of looking at the cloud gaming stuff. You've got the ecosystem and the customer base on there. I do think it's almost unquestionable to me that will be a significant part of the future, but I will not name a time frame on that, because there's all sorts of reasons why it's just barely okay now for a bunch of people, but it's not really good enough for action type games on there, and there's not things that are sort of designed for it. But as we look towards the future, if you can play a video on your computer over the internet, you should be able to play an interactive game at that same sort of quality level on there. Video streaming has all this built-in latency, but plenty of smart people are looking at the problem and cutting it down to sort of bare minimum levels on there. And what a lot of people don't realize is that most games that you play, especially on a living room console TV situation, have more latency in the games as they stand right now than what you get from the internet latency from a streaming solution. One of the things that I tested recently was the Sony head-mounted display, which uses a variation of their normal consumer TV firmware, and it has 48 milliseconds of latency from the time your system, whether it's a PC or a console, says, here's the frame, I'm done with it. By the time it leaves the back of your device to the time pixels start lighting up and sending photons at your eyes, it's like 3 frames. And I know why it happens. It happens because they've got, they support different 3D conversions, they support resolution conversions, 24p to 60p upsampling, copy protection over HDMI, floating menus, and all of those things can be implemented with no more than 1 frame latency, in many cases 0 or simple scan line of latency. But it's more work that way. It's twitchier code to maintain. It's easier to just say, well, we'll buffer 1 frame between each of these. And that's happening in all sorts of places. It's a rare, wonderful display nowadays that has essentially no latency. The Alienware 120 hertz displays and the Asus 120 hertz displays, I put the timing on that, and those are good monitors that have very, very little latency. They're essentially the same as a CRT, but it's shocking how much of this waste is going on in most devices. One of the things that happens with that, one of the great ways to look at all of this is using a high-speed camera to go ahead and video something where you go, I did a lot of this with the head-mounted display stuff, where you go motion to photons and say you've got an input device, you're processing, the communication links, the rendering goes out, and then you finally wind up having a display. So you get something where you take a consumer camera, and it's just awesome that you can buy a camera that costs $200 now, can record at 480 frames per second at a low resolution. And this used to be something that you spent $10,000 for some high-end camera to render, to capture 500 frames a second on there, and now it's just dirt cheap, records to compact flash. So you video that at 240 frames per second, you tap something, whether it's a mouse or a head tracker or something, and you record video until the screen changes. In a fair test, you're doing a full end-to-end systems test, like running the game. But in an artificial test, I have all these things where it just sits on a blue screen. As soon as it senses a bit of input, it switches to a red screen. And you go and you count these frames. And there are so many unfortunate bits of latency in there where you get stuff like if you're running on Windows with multiple monitors on there, you wind up v-syncing before the first change, whether you want it or not in many cases, which winds up having this granularity of 4 of these ticks no matter what. It's trivially easy to have messed up buffering in your input devices, although it's also, you bring ground truth to all of this. Like a lot of people question whether, like the Razer gaming mice, do those really update faster? And yes, you can go ahead and say, it feels nice and smooth on here, but there's always the question of how much are you subliminally giving yourself the answer you want to hear based on the device you bought. But you put an actual real measurement on it, and yes, they really do they shave a few milliseconds off of things. They work better than a standard configuration on there. And that's back to the science and engineering side of things. It's wonderful to be able to measure this, to not just say, feels smooth, feels good. These A/B comparisons are valuable for what they are, but you do real engineering when you've got numbers to put to it. And chasing latency is one of those things. So the comment that I made in looking at the 48 milliseconds of latency is that it was just completely ridiculous. That's the time that it takes to send a packet across the ocean. Not a full ping trip, but a one-way packet there. And that should just ring as absurd in your mind that you can send a signal across, out of your computer, through your Ethernet card or your Wi-Fi even, going through a bunch of routers, going across a cable under the ocean, and come out in someone's computer in Europe. And that's faster than traveling the 2 feet between the back of your computer and the pixels on the screen. That's wrong, and we should stop putting up with that. But knowing that that people right now have a great time playing games under those sorts of conditions there, that does mean that something like on live could provide, if they were able to bypass all of that and have very, very good input, very, very good output on there, but they suck down the network latency on there, then you wind up with something that's not that far different from what many people live with today. And on the game development side, there's actually a lot of things that you can do where many games have multiple frames of latency that are kind of built into the way the game actually works. And even Rage, a game that I obviously cared very deeply about the latency issues on there, the movement latency really is just kind of one frame. It goes to the renderer, then it goes to the GPU on there. But, say, firing your weapon has an additional frame of latency in Rage because weapon firing is driven by the animation system, and the animation system is queued a frame so that we can use parallel tasks to build some of those things there. So firing the weapon is one frame longer delayed than moving the joystick. Now, if you had a faster system where we have to go through all of these things because the consoles just aren't fast enough on a single-threaded performance. We need to run things over multiple threads, and they need to be pipelined. And that's just what we have to do to maintain the frame rate. There's always that tension between bandwidth and latency. If you had a cloud gaming system where you're running on high-end data centers with much faster scalar processors, you could architect your games differently so that you have less latency actually in the game. You could wind up being driven on input packets asynchronously. There's a number of things you can do to pull time out on the server side. And if you look at the game streaming systems right now, clearly they're PC games hosted there, and you suck down all of the negatives of the cloud gaming experience. You've got extra latency, you've got compression artifacts, but you don't wind up getting really the wins that you could get in an ideal case for that. Yes, you can go ahead and have all of your games saved there, you can pick them up anywhere, but you still have to suffer through conventional load times, even on their servers, and it's still a game that was designed for a different platform. And when we look at other platforms like how mobile has evolved, in the first couple years of mobile, there were a lot of games that were clearly designed for other platforms. You bring them over there, it's like, hey, I've got this game, I can carry it around in my pocket now. This is cool, this is fun, I'm having a good time. But they didn't really come into their own until the mobile space developed its own language, doing much more with velocities and swipes and the different interfaces instead of trying to be virtual joysticks on there. And I suspect that something like that will happen with cloud gaming, where when people start making changes to the way they build the games on there, some things that we suffer with in a lot of ways now that we can probably get away from, and we'll look back and be surprised that we suffered with them as long as we have, like game load times. Right now, when you go load up half a gigabyte of data to go ahead and start a level, it sits there and it churns for a while, and we try to do something entertaining while it's happening, but really you wanted to play something and we're making you wait. And we still don't have magical solutions to this, but there are technologies and things that we could do differently, especially in a cloud data center environment, that you should be able to get away from most of that. When you start looking at saying, well, we're just going to memory map all of these things, and you'll have plenty of memory across all of these systems. There won't be any actual spindle access on anything. Being able to get to the point of jumping into any game that you're playing more like you're traveling to a web page. That's possible. It's technically challenging, but I think that certainly 5 years from now, we'll look back and see lots of games that are like that, where you just jump around to all of them and you get a much more immediate experience without having to dedicate 30 seconds of your time to go in and play for a little while. So I still do think that cloud gaming has a bright future. I don't know if any of the current players will live to see the day, because it's going to be sort of a hard start on there getting to that point. But it's one of those things that I consider a technical inevitability, that it really will happen. Other platforms, we've got the VR is the big system that I'm most excited about now. So the story, I've told the story now a couple dozen times in all the interviews at E3, and many of you have probably heard them, but to be really brief about this, after we shipped Rage, I treated myself to I said I was going to go out and get a VR headset and check out what's going on in there, where we had a history a very, very long time ago in the early 90s, both Wolfenstein, Doom, and Quake. We licensed those to a number of companies doing VR in the early 90s. Those of you that were around back then, remember the whole Lawnmower Man and the first kind of birth of the Neuromancer cyberspace stuff, and it was a time of enthusiasm for VR, but it was enthusiasm not backed up by much. That it was too early technically on there. Even the very best systems, like when you get into the mid-90s and you're looking at SGI infinite reality systems, you stack up a multi-million-dollar multi-pipe display system on there, your smartphone can totally kick its butt today in every manner imaginable, really. So it was early, but also a lot of the people doing it, we cut a lot of these deals going, yeah, we'll take your money. No, we don't want any stock in your company because you're not going to be here very long. It was just, there was a lot of high on enthusiasm, low on actual talent companies involved in that because it was a visionary thing at the time. It was, the social change of virtual reality. And in many ways, the larger social narrative about it was sort of downplaying games. Everybody wanted to talk about how surgeons will be doing remote surgery and handicapped people will be exploring and flying around and all of these things when, of course, people just want to play games in their virtual reality. That's going to be the driving force there. And in many ways, when I saw the people that were working the projects there, it was clear that a lot of the people that had the talent and ability to make some of this stuff actually happen were the ones that went into gaming and started writing games and pushing that forward there. So everything, of course, there was the VR crash at that time where a lot of little companies went under, and you didn't hear too much about it, but over the decade after that or more, you'd see them showing up at trade shows every now and then, and I would grab one at GDCs or something and try it out, and they were continually just not very good at all. And actually, let me get a show of hands here. How many people here have tried on a head-mounted display at some point? Okay, that's actually a pretty good number. I would ask every interviewer that I was doing at E3, I would ask that because it colors how your expectations a whole lot. People that haven't tried a head-mounted display, they know what it's like. It's like in the movies. You put it on and you're transported into a virtual world and everything's awesome and cool. And that's the implication. That's what you expect when you look at you see the advertisement for it. You've got these cool mirror shade things or this goggle mount on there. It's like, oh, this is going to be so awesome. I'll be in my favorite game and it'll be like I'm really there. And the truth is they uniformly sucked really, really bad. And I had thought somewhat naively that it's been 15 years since I really looked at this. Surely it's a lot better by now. We have all this crazy advance in technology on here. We have, what's been done in smartphones and the display technology. All of this has just got to be solved. And it's funny when you go into situations like that where it's like a similar one that I had that's actually related to this when I started Armadillo Aerospace, when I thought, surely telling me which way something is pointing is just a solved problem. I can go buy a sensor that does that, and realizing that it's still really not. Okay, you wind up getting gyros and integrating and doing all of this, or you use multiple GPS antennas, but then they have issues with large baselines, and it's complicated. And I had seen a couple other people make almost exactly that same statement. It's like, well, I haven't looked at this for a decade. It's solved by now, right? And you go and I bought a couple head-mounted displays. And they were terrible. They were still terrible. The resolutions were a little bit better than they were back in the old days. Some of the early VR headsets had truly amazingly low resolutions. Like some of them had a couple hundred horizontal resolutions, and they wouldn't even count pixels. They would count like picture elements and counting the RGB triads in there. They were fractions of a TV because they were usually using displays that were intended for going for like small like pocket TV players, the Watchmans or whatever they had back then. At the high end, by the later 90s on there, you did have some pretty more advanced ones that could start putting up a megapixel per eye or so on there. But the consumer devices that you could get last year, you could go spend. There were a few in the several hundred, in the $500 to $1,000 range. There were a few more in the $1,000 to $3,000 range, and then there were professional models that were in the $10,000 plus range, going all the way up to over $100,000. For really high-end displays. So this initial huge dash of disappointment, I look at this and I get something and didn't even really have good demos or anything there, so I wrote something to their SDK, put it in there, and like, oh, horrible latency latency on there, and it was over 100 milliseconds. You look around and the thing slowly catches up to you. And many people that have tried the VR demos, if they're actually head-tracked VR as opposed to just a head-mounted display, sometimes you get a little lecture about, now don't move your head too fast, ease into it, you may not be ready for the whole virtual reality experience on here. Move your head very fast and you'll get completely out of phase with your actual motion on there. So that was beyond the pale unacceptable in terms of the latency there. And it was tempting, a little bit at the time to just say, well, this still sucks, I'll check back in another decade. But I was at a time where I had a little bit of spare time that I could tinker around with this a little bit more. So I started breaking it down to exactly what was wrong with it. Why was it so bad in here? And the first thing turned out to actually be really pretty straightforward, where the sensor... So the things that make up a virtual reality headset is you've got a sensor that tells you something about the motion of the head, communicates to essentially a game system on there where you read in input, but instead of being a game controller, it's reading in some kind of a head tracker. You go do your normal game stuff. You simulate your game world. You draw. You send drawing commands through OpenGL or to whatever you're using to draw. GPU draws it, then it gets scanned out, then it goes to the displays where it may be mangled by other latency-inducing processing time on there. So I built my own little test bed initially for this, and the bulk of this initial latency turned out to be that the firmware that was building a body space, the tell me which way I'm pointing, which is what naively you just want to say, well, tell me what my camera orientation is going to be. And that's tricky with current generation sensors because there's drift issues and there's usually noise issues and bias drifting, and there's a lot of things that make that a little bit tricky. But this is what I'd been doing for over a decade at Armadillo. We used fairly expensive. The difference is we have a box that's this big and costs like $15,000 that has fiber optic gyros inside it. But it's still the same basic thing where you tell how fast something's turning around the axes, and then you do a little bit of matrix math to build up. You say you start here, and you tilt, and you track that as it's going on, and it'll drift a little bit out of there. But I went down to I looked at the SDK again and said, well, just give me the raw values. And I pulled over the code that I had at Armadillo that does that body integration. It's nothing hugely complicated. It's fun to say I used something from my rocket system in the VR demo on there, but it's not that much code. So that turned out to be a large chunk of the latency in the firmware. Was just doing thing. I can only guess that it's because the firmware was for the MEMS sensors of 10 years ago when they were really bad and they were really noisy, and they're much, much better now, to the point that for most of the cases, I'm looking at this $99 head tracking sensor, and I'm seeing the data coming out of this and saying, this is updating at a faster rate, it has lower noise than this $15,000 fiber optic gyro that I'm using at Armadillo. I still scare myself out of actually using one of those because I'm worried about cross-axis acceleration coupling, where most of these sensors it's fine for waving your head around, but if you're taking off at like 5 Gs on there, you get a bias drift. And it's still, when I'm talking a rocket that costs a couple $100,000 on there, it's still worth the peace of mind for a $15,000 fiber optic gyro that definitely doesn't have that. But the upshot was that the sensors today, the cheap ones, are actually quite good. So at that point, it got quite a bit more interesting. When I had relatively low latency from that in there, it was to the point that it looked kind of interesting. The head-mounted displays at that point had the fields of view. In gaming, we talk about horizontal field of view, and I think we can probably trace that back to Wolfenstein and Doom that took this nice 90-degree square horizontal field of view because it made me thinking about clipping a little bit easier back in the early days. And most games have trended down to a little bit less distorted field of view, in the 60 to 70 degrees or so now horizontally. But like TV manufacturers tend to quote diagonal size because it's the bigger number, head-mounted display vendors usually quote diagonal field of view. And you wind up with, well, actually, they try to avoid that number usually. They'll come up with some really bogus description of, it's like a 10-foot screen when you're sitting 50 inches away from it, and you run all of those numbers and you say, that's a 36-degree diagonal field of view. That sucks. It winds up being like looking at the world through toilet paper tubes. This is not the Matrix. This is not the holodeck on here. And of course, most of these, they bring down and you still see the rest of the world around you. One of the first things that I did when I was playing with these things was get a pair of ski goggles, black everything out, and mount one of the displays in there. So it's still tiny, but at least you're not seeing the rest of the world, and you can start focusing on, on updating that part of the world. But still, really not very. There's no way you could say that it's a gaming device. It was just no way at all as an accurately tracked device, at least. So one of the things but I knew that Sony had been talking about their head-mounted display, which was supposed to offer much higher resolution, somewhat better field of view, and it seemed interesting enough that something was on the horizon, so I kept tinkering and improving what I was doing and looking at some of these different things. It's worth mentioning that the Sony head-mounted display it's not pitched as any kind of a virtual reality device. It doesn't have head tracking in it. It's pitched as a portable TV viewer. And there's, the thought being that, well, you don't have to have a big screen TV. You can look at stereo 3D movies. You could, maybe have it on portable, although it doesn't have a portable battery power on there. But it's a TV that you wear on your head. And that's a somewhat questionable design goal in a lot of ways. One of the things that happens is when you look at a flat screen, whether it's playing a game or watching a movie or something, it's a picture hanging on the wall. And as you move your body around on there, it's not an accurate 3D projection. Very rarely do people even play first-person shooters with sort of an accurate field of view. You're always looking at a monitor that's at a different height. It's set up differently. The field of view is much different from what you're looking at. It is worthwhile in many cases, especially like in a 3D TV setting, but even for regular gaming, just to set your monitor up accurately. Go ahead and have the middle of it level with the center of your eyes if that's where the center of projection is. Things like that help. But when you've got the TV, the displays stuck to your head, it means that every little motion that you make with your head, the whole world is swinging with you. It's not that you're looking at this painting on the wall and you're moving around and the perspective's wrong, but it's not, it's just a painting that's in the wrong orientation there. When the whole display slews around with you, that's really not what you want to see. If you're looking at even static content, it's disorienting to move around and have the entire movie you're watching or whatever come with you. And if you're playing a game, it's much worse, because if you're doing if you're playing a PS3 game and you're turning this way and you happen to move your head a little bit that way, the view is doing exactly the opposite of what your brain thinks it should do. And I haven't been susceptible to simulator sickness in general in a very long time. I was never somebody that was really sensitive to it, but I've had a couple cases in this year as I play around with all of these different devices where I'm doing some of this and I don't feel so good after that. And I'm actually really curious if we're going to have anybody lose their lunch with the demos here at QuakeCon. So far, nobody has, but we're going up by at least an order of magnitude in the number of people that will be trying this out on Saturday. So I would not be surprised if somebody loses it at this point, because there are definitely things that you can do that that will not make you very comfortable there. So as a display device, the Sony is a little bit puzzling there, because it doesn't have a tracker, so it's not VR. It's this personal viewer, which is really only good if you hold your head still. If you're laying back in your recliner, and I believe that they demoed this at their stores in some cases, you lay down like on the massager chair or whatever, and you just sit there with the head mount on. And it's kind of neat in that regard, because those of you that have been here for years have probably heard me not be terribly enthusiastic about 3D TVs and the effects from that. And part of that is even the very best of them, you still have ghosting problems. You trade off something else against there, and that is one real advantage of the Sony display is it gives you a completely ghost-free, very vibrant OLED display on there. So it's got some value. I get the impression that Sony was a little surprised that they sold out their production run as fast as they did. I've heard lots of people say that this was a toy project for Sony to use their OLEDs for something else, and that they weren't expecting to sell a lot or make money, and it was an image thing. But they've actually moved a reasonably surprising number of them, and that was exciting to see that there. And the displays start just barely edging up into something that's usable for gaming, where Sony, I commend them for being conservative on their estimate of field of view on there. They call it it's a 45-degree horizontal field of view, which is a big step up from something that was 26 degrees or 30 degrees. it's still not what, if you set a game to an FOV of 45 on there, that's still very, very narrowed on there. It's not something that's a great experience. But at that point, when I had my little toy project running inside, I had the Sony head mount on there, and it was starting to be kind of interesting. I had relatively low latency tracking. I did all the fast tricks that I do for games on there on a fast PC to make sure that that path was very low latency. I made sure the GPU didn't get buffered ahead, and it was kind of interesting. The Sony added this 48 milliseconds of lag, so it was not crisp, and it's a damn shame on that because the OLED displays that they've got in there are wonderfully responsive. As we kind of go through and enumerate all the different display technologies, there's a lot to be said for OLEDs. It's surprising how well people have made LCDs work over the years, from the early smeary, ghosty days with very low contrast and all of that. And LCDs are amazing for the progress that they've made, but OLEDs are really kind of what you want, where black is off, you turn it on, it responds in microseconds on there and starts spewing out the photons. So that's exciting technology there, but to take something that should be responding in a microsecond and then add 48 milliseconds of latency in front of it is a criminal shame on there. And I did finally make contact with with Sony, where it's interesting going through all this, where we sent an email through our Sony channels on there to say, hey, we're using your HMZ for some stuff. This is kind of neat. Could we talk to somebody about some of the flaws, some of the problems that we see with this? And it was just like going into a black hole. We never heard anything back from that. But we did eventually, find the right hookup. Sony is a huge organization. And we eventually did get some contact with them and showed them some of the later stuff that we were working on. And even then, we had somebody that's a VP in one division saying he's going to go talk to the HMZ people, and find out if we can. Ideally, it'd be great if they could get a firmware flash for that, so all the people that have this could, have in the right mode, have a pass through and cut all that down. And that appears to be another black hole. I think they're internal black holes to each other there. But Sony at least is interested in the head-mounted display side of things. They've got both research groups and the product group on there. But 45 degrees, excellent color. The resolution was really quite good. It's a 1280 by 720 display per eye on there. And it's kind of interesting where all the console games, they almost all target 720p resolution, but there are almost no actual 720p displays. This is another one of those frustrating things for a graphics programmer on there, where almost no display that you buy really has 1280 by 720 pixels. Some things like DLP projectors and these little OLEDs, but almost all the TVs that you get, they're either 1080p now, or even before you could get 1080p, when they were all offering 1080i or 720, they were all like 832 or they were this odd number that made sense from a manufacturing standpoint. So you almost never, all of our carefully crafted pixels, they all wound up being stretched and smushed and color corrected and platted onto the screen. It was all very depressing. But so it was nice to have a real honest 1280 by 720 display there. But the optics were finicky on that. And it's one of the challenges when these micro displays, they're like thumbnail size. They've got all of these pixels on there, and they're tiny. So you want to blow them up into something that covers a large amount of the field of view there. And ideally, you want to do that with square edges, minimal color aberrations, and all of these challenging optical things. So when I would give a demo with the Sony head-mounted display, I had this little lecture that I would give to people at the start, where I'd say, okay, you take the device, find a spot where it's focusing reasonably well vertically, then use your thumbs to adjust the interocular separation on there, and then cinch the back down so it sits, it stays on your head like that. Because if you just put it down, it's not good. You have to go through this process of getting it kind of correctly situated on your head there. But it was still tantalizingly close at that point, where we had good-looking displays, the images looked good, they were still small, it's 45 degrees, the latency was not good on there, and I was starting to pick around at a few things, but I was reaching sort of the limit of what I could justify as John screwing around with a little hobby project on this. We have big projects to be working on, but this was about when we Doom 3 BFG project was starting out. We're going to reissue this. We decided we were going to do it internally. And there's the question of, like, how do you get anybody to talk about or care about an 8-year-old project, an 8-year-old game? It's going to be better. It's going to be nice. It's going to run fast. It'll play great and all this, but it's an old project. And I thought, well, I'm doing all this work with the stereoscopics and the head-mounted display. 3D TVs, I have not been a big booster of 3D TVs, but I had the stuff working on there, and it was, it was neat. There's a lot of people that had that. Not many people with head-mounted displays, but I thought, well, we can use that as kind of a press, a PR thing where we can show the press the game in there, and they'll think that's pretty cool. And it's a reason to again discuss the old game there. So when I started working on that, I have come around a little bit on the 3D displays, where one of the interesting things that I had used Shutterglass 3D like all the way back in the Quake 3 days, and I had never been impressed by it. There was always the ghosting problems that were terrible, but it still just never really looked that cool. One of the things that I can look back, all those decade ago on there, and there was one important thing that I just actually wasn't doing right in the 3D stuff. I was rendering 2 views, setting it all up there, but I was rendering it assuming that each eye had its own screen, which is exactly what you want for a head-mounted display, but it's not actually what you do when you've got a screen that you're looking at, because your eyes actually center on 2 different points, and you need an offset field of view, an offset projection matrix on there. So once that's worked in, the 3D is a little bit neater. You set it up. It looks pretty, it looks interesting there. You still have ghosting problems on a lot of the displays. I've played around with different ways to de-ghost by adding extra subtraction of what the opposite frame is, and you can help a little bit there. But even the very best TVs still wind up with some degree of ghosting there. It's actually some cool technology that goes on in the very latest generation stuff, where if you're flipping between the 2 views, well, first to step back on one of the ways to do 3D is with polarized glasses. Like most of the theaters are done that way. And in that case, you can have the projector changing the polarity between there, and it completely changes the view, and you only see half of it through the eye, which is the basic point of all the different displays, whether it's passive polarized or active stereo on there. But the problem is, any of these glasses, they don't block out all of the light. They block out 90-something% of it. But if you have a bright white in a black background, you will definitely see a ghost. There's nothing that we can do about that. The latest TVs solve half the problem, or the latest TVs and monitors, in that when you've got LCDs in the glasses and you've got LCDs in the TV, and they both have to change. The TV is changing from one frame to another, and the glasses are changing from black to clear and black to clear on there. So you've got these 2 transitions, and they're not even the same LCD technologies on there. They're going to transition at different rates. So you were always going to have this temporal overlap period where you were still seeing some fraction of the wrong frame through there. What's kind of cool in the latest generation stuff is when you have LED backlights on displays, you can be scanning your LCD, your transmissive display, and then those still take 4 milliseconds, even the very best ones, to go ahead and change from one color to another on there. But LEDs, like OLEDs on there, you can switch them in microseconds. So you can actually turn the entire display off, change it to another frame, and then turn the display back on, which gets rid of half of it. You still got transition times on the glasses, and you can sync those up. It was kind of neat where one of the monitors that I was testing, I was doing my latency tests on there, so I'm recording at 240 frames per second, and it's outputting at 120 frames per second. And you look at it, and it's this gorgeous, brilliant picture on there. Play back the 240 hertz high-speed video, and you've got black bars over half the screen moving down there as the display is actually completely off, and you don't notice, you didn't notice that at all. And that's, that makes for a really good display. But so the 3D stuff, it's neat. I hope everybody takes a look at the stuff side by side there. But my point had always been in the past that it's not the trade that I would usually make. If I'm going to have twice as much of something, using it for the 3D depth, I think, has somewhat limited general utility. It is sometimes neat in games, sometimes neat in movies, but it's not something that you wind up looking at most of the time that you wind up looking at your display. The thing that I'm happy about, though, is it's making more companies care about 120 hertz refresh, which I actually think is going to be more important in general for people that buy these high-end displays, because And I've checked on a number of people already. If you buy something as a 3D monitor for your PC, a lot of people don't realize that you can actually change that up to 120 hertz on your desktop, and then everything is smoother. Your mouse cursor is smoother, your window drags are smoother. You can run games that don't wind up resetting that, and if they're tearing, the tears are half as obnoxious. And this is all a good positive throughout everything. It's not a mind-blowing thing if you just look at something and scrub a window around. But one of the demos that we have set up here is Doom 3 running at 60 hertz and then at 120 hertz right next to it. And for a casual gamer, it's still not going to make that much of a difference. But if you're a connoisseur of mouse control on there, it really does make a difference. And everybody should go and kind of check out that feel of going from 60 to 120. Now, that contradicts somewhat a test that I had done earlier in terms of reaction speeds and times on there. As I was going through a bunch of this R&D work, I dragged an old Sony 21-inch Trinitron CRT out of somebody's back closet on there, because a CRT, the wonderful thing about a CRT is that you've got voltage coming out of the back of your computer. That voltage goes out and it flies out the electron beam essentially, and it is making it's making phosphors light up in handfuls of nanoseconds on there. It's essentially zero latency. It's the closest thing to a direct output that we've got on there. But I went through, and the other great thing about it is you can crank that up to 170 or so hertz vertical retrace. And I did a bunch of tests taking a game controller on there and saying, well, how does it feel driving around at, obviously, I believe there's a huge difference going from 30 frames per second to 60. But there's some people that still can't even tell the difference at that point. I couldn't tell a difference really going from 60 to 120 with a game controller, but with a mouse, it's really easy to tell. Just move it around on there. It's just got this extra layer of quality responsiveness feel to it. And my take on that is that when you're using a game controller, it's amazing to see people that are extremely skilled with game controllers, because it's really a poor way to interface to some sort of aiming orientation on there, because what you're doing is you're making this precise motion with your thumb, which is not the most precise way that you'd want to do something, rotating it side to side, and then you're integrating over time. It's like, I'm going to move this far and then I'm going to wait a certain amount, and that's not the most natural sort of way to control something. It's sort of two stages removed. Now, a mouse is a directly proportional device. You move your hand 1 inch this way, it translates into this number of degrees there. That is only 1 degree removed, and it makes a difference. I'm far from any kind of professional player, and the 120 hertz sure feels a lot better to me. And the pro players, it was funny for years seeing some of the pro players carrying around a CRT just so they could still get their super high frame rates on there, because that tiny little bit actually mattered. But it goes one step even further, where while anybody that's pretty serious about gaming will appreciate the 120 hertz benefit on with a mouse on there, but when you go into a head-tracked environment, everybody will be able to tell the difference. The problem is, it has essentially been impossible to get a 120 hertz head-mounted display. I actually finally had all the pieces to put this together, where one company makes 120 hertz driver for one set of OLEDs on there, and it's like $10,000 worth of these low lot size parts on there. They don't make a lot of these. These are for basically military sort of head-mounted displays. But I went ahead and bought a set of those, thinking that, okay, I know this is important, but this is not going to be consumer-type devices on here. And I had hoped to be doing that as one of the things I was going to be demoing at E3, when we were first saying, all right, I'm going to show the Sony head-mounted display, which it's kind of neat in Doom 3. You can have the field of view there. You really wouldn't want to play and fight your way through the game like that, but it was still interesting. Enough people had still been impressed by what you could do in there that it was worth showing and talking about. But I thought if I could get the 120 hertz displays, that would be one additional sort of level of of interest to show there. But so I wound up with a bunch of problems with that. But what happened in the meantime on the way to that was, I guess I should also say, a couple of the other experiments that I did. I had spent a bunch of time building things with these little laser pico projectors, where I was looking for ways to get these wider fields of view that I thought was super critically important for this. And I was looking at a lot of ways to project onto curved surfaces using these, they're interesting little devices, the microvision laser pico projectors. It's again one of these things where I'm not sure actually what the supposed market is for these things, where you can plug it into your cell phone and you can play, Rage HD or a movie or something projected up onto a wall, but they're not really bright enough to do in any of the places that you'd want an impromptu showing there. You have to darken a room and have a reasonably set up place for it. But it's a neat gadget, it's not that expensive on there, cheaper than a lot of displays, and it was kind of fun to tinker around with. But one of the things that I have mentioned in past years at QuakeCon is the appeal of direct laser retinal scanning, which of course everybody's like, shine a laser into your eye? What the hell? But there's a lot of things that are enticing about that, especially for someone with poor eyesight. The idea of scanning a single beam of laser in there, you can still have malformations of your optical system on there, but you bypass a lot of the focusing issues that your eye normally deals when you integrate light across the entire surface of the lens, and you've got all the different corrective problems there. So I've always been kind of fond of this idea of eventually being able to, scan a sharper than reality view directly into my eye. And I was working on setting up different interfaces for some of this stuff, and by then my office was acquiring a lot of clutter of Edmunds optics and various little pieces of, lenses and mounts and all the video cables connecting all these things together. And I did actually get to the point of very, very cautiously, making a laser projected an image. And I'm like, okay, red channel only, least significant bit, brightness at minimum. Check it with a card to make sure there's no focusing point there. Then very carefully get down and and get a laser imaged onto my eye. And the funny thing was the guy at Microvision that I was talking with about this. I had sent him an email saying, I'm thinking about going and testing this. And I had already gone ahead and done it by the time his email came back saying, no, don't do that. Your eyes are too precious. But the thing that I learned on that is what Microvision had also learned in some of their research is that it sounds all great that you're just going to have it's like ray tracing in reverse. You've got this pixel on the screen is coming in at this number of degrees, and we're going to shine it into the eyeball at that number of degrees, and it's going to focus in on your retina, and that'll be the proper image. And that's actually true when you're looking straight at it. The problem is that when you're looking at any given spot that you're seeing in your eye is actually light that's coming from, if I look at some point in the distance there, light from there is coming out, and it's forming a cone that covers my entire eye. And your lens focuses those photons from all of those points coming down to it. So even if part of your eye is occluded in different ways, you still get something from that focuses in. If you've got a laser beam coming in, it hits one point on there, and if that point goes off the side of your eye, then you have nothing at that point. So just these tiny little motions. So you've got this cone of laser light coming in, focusing in down there towards your eye. And when it's coming in and it's hitting part of your lens, it comes in, hits your retina, does exactly the right thing. But as soon as you look one direction a little bit, then that corner of light that was coming in there is now hitting a part of your eye that doesn't focus in there, and that part of the world just kind of fades out. So there's a severe vignetting problem with that, where you look at a scene, it can be just right, and as you look side to side, the world fades out here or there. So when I finally understood some of the issues with exit pupil and focusing on there, I've learned actually a whole lot of Newtonian optics in the last 8 months or so on this. So that dashed a lot of my hopes for the laser retinal scanning stuff on there. There's a lot of work that does go on with being able to widen the beam and have it come out from multiple points, but by that point you're losing much of the benefit of these cool tiny little laser projectors that you can that you could mount easily in a lot of different ways and project onto lots of different surfaces. Now, I still have sort of an interesting theory that it may be possible to have a small array of laser projectors to solve one of the currently unsolvable display problems. And one of the things that once you solve everything in displays, if we have our magical display that has infinite resolution, infinite frame rate, infinite dynamic range, if all of those things are solved perfectly, you still have the problem of you are looking at a flat surface that is a fixed distance away from you. And this was another thing that I didn't really appreciate before all of this work, is how important the focusing is for kind of telling depth in some places. Depth from focus is one of the common ways in robotics and video processing that you can figure out some of the stuff around you in an environment. But I was noticing that more and more, like when I'm in these virtual environments on there and I'm leaning over a table in Doom 3 and I'm looking at the table, and then there's the ground below that, and they're both perfectly in focus. I lift up the head mount and I look at my table and the floor underneath there, and you can tell much more as you change your point of focus between there. Or even the case of if you've got one of those poor unfortunate monitors or TVs that has a mirror-like glass face, how you can find yourself focusing on the screen or focusing on what's in the reflection that's actually 10 feet behind it there. And my harebrained idea that I'm still interested in pursuing at some point is that you may be able to have a small array of lasers so that the optical effect that the eye does, instead of convolving an entire light field on there, it may be possible to, say, have a triad of laser points on there that you could adjust the focus on independently. If you could have stippled dots so that at the focal point they come together or they spread apart, and you'd be able to kind of optically focus at different levels. And that would be very interesting, to be able to have an image displayed where it really has variable depth of focus and your eye can change its focus across the different points. And that is actually different than retinal tracking, where you can figure out what you're looking at and change what you draw on there. The other interesting idea that I had that also didn't pan out, but was one of those things that sometimes you get those things where if this works, I'll be a genius. This will be fantastic. And my thought was that you've probably seen some of the image processing stuff where you can take a very blurry image and sharpen it back up by not just doing a simple sharpen filter on there, but you can actually invert the entire matrix of an image, doing these really serious number crunching things. And it really is almost like the movies, sharpen, and pull a lot of that information back in. If it was actually there, you can't do it from a low resolution image, but a high resolution image that's been blurred by a convolution, you can invert many of those convolutions and make it sharper. So the reason that you can't just take a display and hold it up to your face like this is because your eyes can't focus at a very, below a minimum distance. And that's why some people need prescription glasses that are different for reading and up-close things on there. Your eye just can't form an image properly there. There's one crazy company that's making special contact lenses that will allow you to focus on something very close if you're willing to put a special VR contact lens in, which is kind of a cool idea. But my thought there was, well, can I make an image that's actually over-sharpened so when it's blurred by the eye not being able to focus on there, it comes out at the appropriate sharpness level? And I was thinking, well, mathematically, I don't see any reason why that shouldn't work. Okay, there's probably dynamic range issues when you do an inverse convolution of this, I might have to reduce the dynamic range. Maybe even if I could only have one bit, just at 50% grayscale, letting it go above and below, that would still be really, really interesting in many ways. But it did one of those surprising math things where it went, the solution just was completely unexpected and bore no resemblance to the original image. And that's one of those things that, I do not have the math to properly analyze why that happened on there, but I still want to kind of experimentally investigate it a little bit further, because that idea still seems like it has some promise of building an image that's expecting to be later dealt with by the optical system in a non-optimal manner. And so all those experiments that I was building, I was going ahead and I had built a few of these things. And one of the things I was looking at, some of the cases, like you have a laser projector and you just have a box, have a big giant box on your head at that distance, just to have a reasonably wide field of view project. Obviously not something that you're going to wind up selling or even showing to somebody else, but perhaps a way to have a wide field of view. But at about this time was when I first came into contact with Palmer Luckey and his Rift prototype on there. And there was the MTBS, the Meant to Be Seen in 3D.com on there. They have a forum for people talking about virtual and augmented reality. And I had been lurking there for a little bit, just kind of learning the lay of the land. And he had been posting kind of his progress of building significant homebrew head-mounted displays. And I contacted him. It looked like he was actually at the point of having something that was really exciting, like 90-degree fields of view, very lightweight, just interesting here if it was all it was cracked up to be. So I sent him an email, told him that I've been working with the Sonys, and I'm going to be doing a demo at E3, and I've got these 120 hertz things that I'm working on, and the Sony as a baseline. Wondering if he'd be interested in letting me take a look at what he'd been working on. And that was one of those times when it's good to be me. It's good to have people know who I am. And he sent me the only prototype he had on hand, just kind of no questions asked, and mailed it off to me, and it was really pretty amazing, where at this point I'd tried, a half dozen different head mounts on there, some of them fairly expensive. I had 10 grand in parts on this one that I was working with. And at the time, he was talking about making this as a $500 kit. He figures that he could source all of these parts and put it together for about that. So it's a really simple idea, and it's what I was coming around to after giving up on the lasers, where the idea is that, well, if you just have something like a tablet or a smartphone on there, and you put a simple set of lenses in front of it, and you can use pairs of lenses to have a proper exit pupil, or use simple magnifiers deal with distortion, different things. But the idea of just, I had all this, I would have these eyepieces, and I would pull out my iPhone all the time and just kind of look through the eyepiece at there and say, well, it needs to be bigger than an iPhone, but smaller than an iPad, something in that neighborhood tablet-wise. And I made some rough looking around. I was still harassing a lot of different LCD embedded companies about 120 hertz drivers on there, without any luck. But I hadn't sourced like exactly the right sort of panel. But here was Palmer that it looked like he had picked out exactly the right parts for this, and it looked like pretty much what I wanted to do. He had just gone and done it, before he even knew I was interested in working on any of this stuff. So when I got it, the field of view really did deliver. It was, you jam it all the way up to your face, and it is a 90-some-odd degree field of view on there, vertically, actually more than horizontally, because what it actually is, it's a 1280 by 800 display panel. It's this little 6-and-something inch panel with a set of optics for each eye there. And you look through the eyes, it's relatively low resolution because you've got, instead of having a display for each eye, it's one display shared by the eyes, which in many ways is much, much nicer from a programming standpoint. A lot of the cheap consumer head-mounted displays, they would have a separate little LCD for each eye, and you could go into this frame toggling mode where you could go into either having the image come out at 60 frames per second to both of them, or you could toggle between them, and you would have this swap left and right button when it gets out of sync on there, and your eyes are backwards, and you swap it back, and it was just really not a good arrangement at all. Having one display where you just say, okay, you render the left eye on the left side and the right eye on the right side, and everything is good, is actually really nice for a programmer. And the real problem with this basic setup on here. So, okay, it's low resolution, but resolution was not at the top of my priority list. But the optics in it wound up distorting the view quite a lot. It had a really pronounced fisheye effect on there. That has a beneficial effect when you think about it, in that you get more pixels crammed into the center than there are around the outside, which is it's not as effective as you might think, because your eye can actually go plus or minus 45 degrees without moving your head at all. So even if you have an awesomely cool screen here, you could be looking from one end to the other just by changing your view without getting picked up any motion by the sensors. But it is still somewhat nice. When you move your head around, you can focus in the center a little bit better. But still, it's low resolution. But it's distorted around the outside. So when you're doing a good job at virtual reality, you want to have the world matched up so that it's physically accurate. So most VR demos, again, if you've tried them, they may be, if they're showing a game in there, they're probably pretending they're a mouse. They'll go ahead and have a head tracker, and we'll say, okay, we'll turn this into horizontal mouse motion, this into vertical mouse motion, and we'll pretend that this doesn't exist. And you're scaling it by some sensitivity value such that you're looking a little bit this way or that way, and it's moving the world a lot. And some people even try to consider that a feature. Well, you can turn massive amounts by doing that, and that's kind of what you do with Track IR on there, but that's looking at a fixed screen, so you've kind of got an excuse for it. But what you want is to have the world mapped correctly. You want to have the field of view actually accurate. Now, nobody would do that on the old ones if you only had 30 degrees field of view. You would still, if you were playing a game there, you would set your game to 60 or whatever, and it would be a distortion. So even if you did have head tracking on there, the world would be squishing and stretching as you looked around because it wasn't the right window there. But you pick the right field of view, and you pick the right scaling on your matrix so that you want to know that looking straight ahead is straight ahead in the world. Look straight down, you're looking straight down in the world. 90 degrees, turn around. You want to have it mapped properly to the world. So if you've got warping in the field of view, that means you can be moving around looking at this, and it's got this pretty bad swimming behavior. But this is one of those things that we can so fix that in software nowadays. And I was having that argument with some of the other head-mounted display vendors about saying, look, we can totally warp all of this, because I was working on the laser projectors where my idea, I was projecting onto a dome. So I worked out all the warps to be able to say, well, you could even take a 180-degree field of view, project it onto a dome down there, and I was just doing all this in a fragment shader at the end. It's not all that complicated math on there. And so it didn't take me long to work out a proper distortion correction for the optics that are in the Rift. And at that point, things started getting really pretty significantly cool, where you could have the game on there and look around and you're like, wow, this is actually something. It's not the holodeck. And it's funny, I realize I'm kind of dating myself by even making holodeck references when I think back on here where when id was founded, we did have, we took breaks to watch Star Trek The Next Generation 20 years ago, and we've got people here that weren't even born at that time, but it's not there yet. The latency is still not what it needs to be. The resolution's lower, but there's a clear sense that this is not of the same class as what has gone before. I had a technology demo bit that I had done. I actually had a piece of Rage that I was using for various graphics research things. I was doing, a number of little rendering technology demos, and that was what I initially used for all of this work. And it was nice because it was separate and fast, instantaneous compiles, and it was easy for experimentation. And that was cool because there's so much detail in Rage that I spent so much time in this one little part of Rage, and I would still see all these, that brick and that mark, and there's just detail that I never even appreciated playing the game for real. And I saw that every time I would spend some time in the VR space there, is that a lot of this detail, I'm sure, our poor artists spending all this time doing this stuff that 99 people out of 100 probably just breeze right by and don't appreciate. But in there, when you're looking around and you can move your head and everything's, when you're walking by, you see something kind of interesting, you look over at it, and it draws your attention, and that's really just as it should be on there. So it was interesting with a bit of Rage there, and Rage has a pretty good geometric complexity and excellent texture detail in there, because for a small piece here, for a test bed, I didn't want to pull over all of the mega texture stuff, so I just extracted one 16K by 16K chunk of a level on there, which is like a gigabyte of texture data uncompressed, and it looks great. If we could have shipped all of Rage that way, it would have been a terabyte or so of at least that for the entire game. And that would have been great, but obviously we couldn't have shipped that. But when I put it into Doom 3, and we're like, okay, now we've got an actual game. We've got a real game with characters moving around in there. We went from a static world, which had lots of nice detail, but you're just no clip flying around on there. But when you get into the real game, and just like in the start of Mars City, walking around the cafeterias and looking at the tables and looking at the characters, in that, it was starting to get really pretty interesting there. Then when you start say, okay, everybody wants to, it was kind of funny, Tim would be telling people about all of this stuff, and Tim would pitch the story about how it's awesome when you're kind of dodging fireballs and doing all of this stuff, and we're sort of making that up at the time because we hadn't really done all of that yet at that point, but it turned out just like he said, it really is awesome getting in there, and interacting with the live environment in that way. And you have the case of, again, older technology, older graphics, lower fidelity on all of that, but it's live and real, and you're playing in and interacting with the game. So we are, I want to make sure I don't oversell what it actually is, because it's important to have, anybody that's seen previous VR stuff, your expectations are already well calibrated, and you'll have a great time on there. But for the limitations of what we've got here, and the plan is that we will have one, hopefully two units here on Saturday that we'll let everybody come by and play. We'll just have a line and queue people through that. We're going to be using them for press demo stuff tomorrow, but I hope that everybody that wants to gets a chance to spend 5 or 10 minutes with this to kind of gauge the experience on here. It's not done yet by any stretch of the imagination, but it is clearly pointing an arrow in the direction of where we're going to be going. The downsides to it right now are it is limited resolution. So each eye gets 640 by 800 resolution. So it's actually more resolution vertically than horizontally. That means that you can actually, if you look carefully and you've got good eyesight, you can resolve the individual parts of the pixels on there. It's blown right up in your face. So some people that are all about super crisp detail on there, it's not there yet. But on the upside, that's riding the kind of mobile device freight train of technology. We will have 1080p panels, probably they will be available by the end of the year. There's a 2.5K resolution panel that would be ideal for this that Toshiba's been demoing. We haven't seen engineering samples on this yet, but it would be ideal for that because it's a little bit larger. You could actually unmask that, and you'd have 110-degree horizontal and vertical resolution, awesome resolution. Those parts exist. They're just not quite commercialized yet, most likely because the chipsets can't actually drive all of that yet. One of the interesting things there is I want all that resolution. I want 120 hertz update rates on there, and that turns out to be pretty hard for even a top-of-the-line PC. It's the first time in years that I've wanted a multi-GPU card because I can actually saturate my current top-of-the-line single GPU card, not rendering all the frames that I want to be able to render. I want to be able to render at that resolution. And there are some companies that are looking at displays that may be that much resolution per eye that you might be able to render at those resolutions. So you're up to some very demanding bandwidth and rendering numbers on there. So scale your expectations for resolution low. The tracking on it is measured between 40 and 50 milliseconds or so right now. I do everything possible on the software side of things. Like one of the interesting things that I do to save a frame of latency, and I may do something like this as we go forward into future Tech 5 games, is the way Tech 5 works right now is you sample a user command, you pull in all of your data from the joypad or mouse or whatever, you pass that to the game code while it runs in parallel with the render from the previous frame. So the time that input gets to the GPU, comes in, goes through the game, goes through the renderer, then it goes through the GPU driver and GPU actual rendering, then it comes out the back. Something that I'd meant to try for years is forwarding head corrections on there, where while you have the game running in parallel with the renderer has already, it knows what it's going to draw. It's all been latched on there. I go ahead and I calculate a forwarded matrix where I say, all right, game, this is what you're going to be next time, but calculate the delta from this to the last frame. It's going to be these relatively minute movements, and forward that to the renderer and say, okay, render everything that you were planning on rendering from the last frame, but go ahead and add this extra little bit of rotation into it on the head. And that works surprisingly well. Now, if you have something that was just off the edge of the screen, like you had it stopped drawing everything there and you snapped your head all the way over, you might be able to catch a glimpse of something that wasn't there because the renderer didn't know it needed to render it. But especially with Doom 3, with the really large polygons on there, it's really a non-issue. And what we generally find is as long as it's drawing black or something appropriate like that, you don't really notice the screen coming in a little bit. So save an extra frame of latency there. All the good stuff of making sure the GPU actually syncs, because for benchmarking reasons, if you don't sternly tell them not to, most GPUs that are fill rate limited will wind up buffering up more than one frame, which can add additional latency. Going all the way back to the really bad old days of like Voodoo, where you could have a whole second's worth of mouse moves latched up in your GL Quake time or something. But that can still happen to a frame or so of delay in graphics drivers nowadays. But we force syncs and do all this stuff to make absolutely sure that they don't do anything wrong. But we still wind up with the three things that are currently problematic that prevent our latency from being really, really tiny. The displays on the current Rifts are an embedded LCD panel where it's not, it's an older generation LCD. So it takes about 20 milliseconds to go from gray to gray time, kind of the response time of an LCD. The best LCD panels now are in the 3 to 4 millisecond range, which is really quite an engineering achievement in a lot of ways. But this is not that. There is a long kind of bleed time. Now, you can spin that a little bit as a feature where it's like, okay, tear lines aren't as bad because it's blending between them, but it's you wish you didn't have that. Then the other major one is we're still stuck at 60 frames per second on there, which turns out to be, I found one really interesting case in my work that brought this home, that highlights another aspect of displays. Once I got all this other latency out, and I was working on the fast OLED displays, narrow field of view, but I was still using them for responsiveness testing on there. If I had a hard vertical line, like a door frame or something, and I would rapidly move my head side to side like this, you would just swear that the whole world was shearing, that it was warping. And I spent a lot of time thinking that my gravity vector tracking on the head tracker was factoring it in when it shouldn't be, and it was actually tipping the view. But when I finally realized that that's actually the slow scan of the raster, where there's a 15 millisecond difference between when the first line comes out and when the last line comes out. We render at an instant in time. A given time, we render a snapshot of the world there, but it gets scanned out incrementally. And in most cases, that really doesn't matter. There's very few cases where it really makes a difference. Rapid tracking in a head-mounted display is one of those cases where you can tell the lag in time there. And in many ways, we'd be a little better off if even if you were stuck at 60 frames per second, if you could squirt all 60, the entire frame in that time period, and then flash the screen at that instant, you would at least have a consistent time rather than having the time that actually changes as you go up or down. But that's one of the real problems. That's at least 50. It's a variable time from 1 to 16 milliseconds based on where you're at there. And then there's still room to get something out of the input tracker on there. So we're at this 40 to 50 millisecond range. Now, something interesting happens at around 20 milliseconds, and I could get to these numbers by playing with the OLED displays, not V-syncing, rendering 1,000 frames per second, so you get lots and lots of little banded areas that update very quickly, and also the brief time messing with 120 hertz displays there. At about 20 milliseconds time, you get to the point where if you're looking at the view and say you're tipping your head side to side where you decorrelate the horizontal and vertical motions, which are easy for your brain to track, but tipping side to side with the current demo that we've got here, 40 to 50 milliseconds, it's responsive. It's probably far more responsive than any of the VR demos that you may have tried before, but you can still tell that you're pulling the world along with you. At 20 milliseconds, it feels like you've got a cutout in front of you, and you're moving it in front of a stable world. And that's really pretty magical there. I still feel that there's the next thing after that where it works at that point definitely for the roll motion. When you've got the other tracking, you've got a lot of other things that your eye is doing with following and focusing where even 120 hertz may not be enough to be perfect for you to really believe that you're looking into a world with no lag that has no simulator delay. But my bet is that that's the magic number for immersive VR. Now, augmented reality is a whole other story. And, I should mention that it does look like Michael Abrash still is going to be able to make it to tomorrow's panel. We thought that there was an emergency that had come up, so he didn't make it in today, but it looks like, fingers crossed, he is still going to be here tomorrow. So he's been at Valve working on augmented reality stuff. And, of course, he was my right-hand man in the QuakeCon programming days. So it's big Michael Abrash fan. I'm glad to have him back for this. So it's going to be fun to talk with him and Palmer, who has a lot of experience with a lot of different head-mounted displays. So that should be it. We should be able to go into a lot of interesting detail about all that stuff tomorrow night. But so again, the demos that you should be able to see on Saturday, note the resolution, note the slight delay in latency on there. And then the other important thing that you can't do in this is you can't actually translate your position on this. I'm only using rate gyros and accelerometers to get your kind of which direction you're looking. One of the kind of clever things that's in there is it does have a little model of your head and neck so that as you look down, there is some parallactic motion. And that's one thing that I think even a lot of regular games should consider doing this, because your eye actually picks up a lot of your depth information from these very, very subtle motions of your head, and not so much from the stereoscopic view. And this, in many ways, in fact, I'm sure I would take accurate positional information over stereoscopic. I would take a monoscopic head-mounted display with really, really good absolute position sensing as well as orientation over binocular stereo. Of course, best case, you want everything, but that is a really powerful effect. I've got a little bit of it there that I sort of calibrated myself doing this kind of look around, and if you're about the same dimensions as I am, there's going to be that one field where, yes, that looks completely natural looking down, the floor looks like it's solid, but any other changes, sharper or more leaning at the waist, then, the floor will not feel like or will not look like the floor that your feet are standing on, because it doesn't know that your view should have moved an inch forward in virtual space. It just knows that you pivoted this amount and had this little modeled space. So the floor doesn't track exactly what you want. And that's the other way that I found I could give myself simulator sickness a little bit in this, is looking around generally pretty good, but if you stand and look down at the ground and you sway side to side, so at that point, you're not changing your orientation at all, just a very tiny amount from sort of the pendulum there, but you're moving a fair amount there, so the world to your eye feels like it's swinging on a pendulum underneath you, and that's very disturbing. Yeah. It's like, if you want to try that in the head mount, do that last. So it takes a little while to kind of settle down after pushing through that. So that bit of the world not doing what you expect it to is still an issue with the simulator sickness. Now, I have one of my R&D demos I used a bunch of different sensors for this, where actually the first thing I tried was the Microsoft Kinect for Windows on there. And the thought was, well, I'll just, I can track the head on there and figure out and maybe do some other interesting things. The problem with that, it just gets completely killed by latency. The Kinect on Windows runs a little bit faster than Kinect on 360, or at least the demo stuff does, but it wound up being about a 70 millisecond time from wave your hand in front of the camera to the time that the processed stuff winds up showing up. And when I'm looking at times of wanting to shoot for 20 milliseconds, obviously 70 milliseconds of sensor latency is completely unusable in any way on here. But a better version was the Track IR system, which is this little IR camera you sit on top of your monitor and you wear something with IR tracking dots. And they pitch it for gaming stuff where you can do some things like they amplify the motion. I don't know anybody who actually plays an FPS like this, but you can have small head motions turn into large amounts of turning. And it actually has quite clean data. It updates at 120 frames per second, and it gives pretty good positional and angular information on there. And in some ways, when I got into that, I thought, okay, this is really neat. All those subtle motions are very important. The killing factor for that, though, is that it's only got a narrow field of view. So as soon as you move enough and one of these little tracking dots falls out of the field of view, it can't give you a proper solution for where you are. And it is so incredibly frustrating you're in this virtual environment on there, you're looking around saying, this is really cool, I'm looking around, I want to look at that, and you're just in the middle of a natural motion, and then the matrix sense solution goes away on there, and it is, it just kills the experience. It's not useful for a VR, for a real good immersive VR. I got to do some other neat things, like I did Fish Tank VR, where I had the regular, I was hacking on Rage at this point, the regular game running there, and I took the viewpoint modified by the Track IR, so you're looking at a normal 2D game, but you can move your head around, and it changes, and it's set up exactly as if that was a window on your desk looking into the world behind it. And that was pretty cool. That was interesting. It's not clear that you'd want to play a whole game with the proper positioning and stuff there, but you might, and that would be another one of those things that I think is worth coming back to. But the thing that was closest to the right thing on there, but frustratingly still a little far apart, was the 6th Sense Razer Hydra, which is a magnetic tracking system, which is a consumerization of a lot of stuff that was used back in the old days of VR on there. But when you buy it from Razer, it gives you it's basically like a 360 controller broken in half with motion sensors that are actually absolute sensors in each side. And in many ways, that would be really, really nice for a VR situation on there, where certainly if you wanted to use that for your hands or something in there, that would be interesting. But what I wanted to do was take the sensor out of that and use that for the head tracking on there, because it gives a solution. It gives you position, it gives you orientation, there's no drift. It seems ideal. The frame rate, the update rate isn't as much as you'd hope. It updates at 250 hertz, but it takes 4 updates to make a full update. So really, it's 60 some odd hertz on there for full solutions, but still not bad. It had maybe 20 milliseconds more latency than the gyros, and when you put that on, there is a fundamental coolness to having that position information there. Like, one of the things that I could do, unlike the Track IR, where you just have a cliff that you fall off, where it's working great, not working at all. The Sixth Sense degrades gracefully. So the closer you are to the base station, it's really precise. They get millimeter level accuracy there. But the further away you get, the noisier it gets, which is just as you want. It's a graceful degradation. And the range isn't great on it, but if I have that base station on my desk and I've got that there, I can lean over it. And what's deeply cool is I could have that on, then I could sit down, put my hand on the virtual floor, be looking at sometimes the pebbles that were actually modeled in Rage in some places, little scraps of things there, and crouch down, lean over, and look at it. It's like you feel like you could actually flick something on the floor. And that is importantly cool as an aspect of the virtual reality experience. But unfortunately, the Sixth Sense, as it stands right now, while it offers good precision, it offers poor accuracy in that it gives repeatable values that are millimeter level in position and decent enough on your matrix orientation solution on there, but it's a very lumpy configuration space. And if you're using it for gun pointing or a lightsaber battle, nobody cares that you're 10 degrees off. But if you're using it for your head orientation, you turn here and your view is 10 degrees off, that's really unacceptable. So the right thing to do is to integrate, fuse the sensor data on there so that we use the rate gyros for the orientation and pull the position out of there. I spent a day or so trying to build a calibration map for it because, again, it's repeatable. And so I built all of this network of, I would calibrate all the points and map them from gravity vectors. And I built a nice calibration matrix where from this initial position, okay, I've got that calibrated correctly. But unfortunately, it's a couple 6-dimensional problem on there. So a 2-dimensional calibration map and the sparseness that I could achieve in 6 dimensions, it wasn't working out really well. It's one of those things that I think it would be better addressed at the firmware level on a per-channel calibration. The CTO of Sixth Sense is now at Valve, so there's a good chance that there may be some hacking going on at the firmware level there in the future. But it is still possible to integrate, track that, calibrate the orientation, so you have to still know what orientation you are relative to that for the position to mean anything, but you can make that work. The guys at Valve have their test bed integrated like that, and I didn't quite get enough time to do that. And it's one more cable that winds up going down the system on here, so that is not in the demo. So the three things that are immediately obvious when you think about VR that are yet to be done right on this is resolution still too low, latency still too high, and we don't have absolute positioning. But all of those are present in some degree. The resolution is good enough to be cool, the latency is fast enough to be cool, and the tracking with the orientation and a little bit of head-neck model is interesting enough to be cool on there. So it's all there, but the exciting part is that all of those things that aren't yet exactly what we want are all solvable in the imminent future. The 120 hertz stuff is mostly a matter of getting some of these board vendors to just care. In many cases, I don't think they'd have to change much at all. While a lot of these things are only spec'd to operate at a certain amount, it turns out you can run them higher just fine. Just nobody has cared about wanting a 120 hertz display in a small form factor. And so I've been going around kicking a lot of trees, trying to push lots of different companies into being involved in this in different ways, where I think NVIDIA is in a wonderful position to be excited about something like this, where obviously in the near term, here's a reason for multi-core GPU, multi-GPU chipsets on there that can suck up all of this performance that you can throw at it on there. And as we look further forward, eventually all of this is going to be wireless. Clearly, you're going to have something that is the it's the equivalent of a tablet or a smartphone with optics on it, and everything is there. You put it on, there's no wires. You can start doing free roaming, walking around the world, doing different things, skin the world in different cases. That's obviously where it's going, but we need a couple more cranks of Moore's Law to get to the point where we're doing that. But, so it's a Tegra 6-based platform or whatever it winds up turning out to be. Getting the ball rolling there, I think, is excellent. Intel's excited about this stuff because it's a wonderful way to use Thunderbolt as an interconnect on here, where our prototype here has like 3 cables coming down. There's a video cable, there's a power cable, and there's a USB cable to the tracker. And what I pretty firmly believe is going to win is optical tracking for the there's a lot of things we want to do with that. So you want to put a pair of stereo cameras on the front of that. So for one thing, you would be able to go and tap the side and get pass-through augmented reality, because this thing really does block off all your view. You're groping around blind trying to find your game controller or put your headphones on or whatever on that. So you really do want some ability to do that. And you probably want that as a safety factor there also if you're doing orientation tracking and environment sensing. You want to know if you're about to headbutt something on your desk there as you're moving around. So that adds up to a lot of bandwidth when you start looking at this. Say we've got you can blue sky. I was able to play around with one of Emergence's high-end displays that has 1920 by 1200 per eye. So that's a lot of pixels that you're looking at over there. Right now they're going over 2 separate DisplayPort cables on there. And then say you want equal resolution on your cameras coming in. All of a sudden, already we've blown past what you can do with Thunderbolt today. This is a reason for Thunderbolt 2 or 3 or whatever we need on there. When you have multiple input streams running at 120 hertz, running at those resolutions, and those will deliver some real value there. So, Intel's interested in there, and I'm trying to push them to get some of their, optical research people to work on this, the optical position tracking problem, which is a hard, unsolved problem in the general sense of saying, given a pair of images, give me an accurate map of exactly what's going on. And people have been attacking that problem for decades. And you've got some pretty good stuff, but it's not something that you can nail down and ship it right now. But my theory is that you can simplify that problem and solve what we need to on this by trying to make an optical rate sensor for attitudes, where not so much say, tell me where I am at XYZ in this position, but instead tell me from optical flow analysis, how fast am I moving in XYZ as well as my angles on there. Because just like we don't care so much that the gyros drift a little bit, if you didn't correct for this, you swing your head around a whole bunch of times and the view will wind up being 20 degrees off. So we've got all this stuff in there that it measures gravity and knows which way is up and it corrects towards this. But we can do this in position as well. It doesn't matter if you slowly shift a little bit on there. What matters is when you're making these translational motions, having the absolute orientation equivalent of a rate sensor would be absolutely good enough for what we need in VR. And I think that's a solvable problem. It's not a trivial problem. It's the type of thing that it's an excellent little PhD research project for somebody on there. And it's been great to see, Microsoft. It was great to see Microsoft commercialize a lot of the research work with Kinect, and this is actually probably an easier problem than Kinect there, and somebody should be getting to that. But so, Intel has interest in that. We've been approached by, lots of people about how do we commercialize all of this, and I'm almost a little scared that things are moving too fast right now, where my initial thought on this was that we know a bunch of stuff will be better a year from now. We'll have better displays. There'll be more software that supports it. And the original goal that Palmer was doing with Oculus was, I'm going to make 100 kits and sell them to the VR community. The guys that hang out on this board and we chat about this stuff, we're going to build some of these so everybody can run their experiments on them. And in many ways, I thought that was going to be a really great thing, because there are things that need to be figured out about this, about different ways to interact with it, all the right ergonomic issues about how these things should be built, the standoff from the face, do we need focusing or interocular adjustment on here? There's a lot of questions that still need to be answered. But things kind of blew up after E3 when I demoed to journalists for the first time on this. It was it was an interesting thing where I had shown maybe a half dozen people at it what I sort of had on there. I had started making the changes in the game to make it, like decoupling the weapon, disabling some screen effects you don't want, and like head kick effects in 2D you definitely don't want in a 3D VR headset. And there are a number of things that had to be sort of disabled in the game to make it actually play really well there. But I'd only shown maybe a half dozen people. We went to E3, and I had a day of interviews scheduled. So people come in, I give them the show, and I talk about all of this. They play for a little while, and then I was going home the next day. But we had such a response from the people on there that everybody was talking about it. We had people saying that they had just been to Nintendo, Sony, Microsoft, seen everything that they've got to show, and my God, this was the coolest thing that they've seen at the show. And this was, my thing with, I duct taped on a headband on top of Palmer's. It had hot glue holding the sensor on and a little foam wedge under there to line it up properly. This was very much the picture of a little homebrew project. But for many people, this was fundamentally cooler than all of the other Flash stuff that was going on there. And we wound up scheduling another day. I stayed another day and gave a whole other batch of demos on there. And the press started hitting, and I had warned Palmer ahead of time. I'd been very explicit about this. Okay, I'm going to do this E3 thing, and people will report this as John Carmack's head-mounted display. Just brace yourself for it. I will get the transcripts. I will correct everything I possibly can on here, but it's still going to come out that way. And lo and behold, it did. It worked out really well all around. But the problem is, everybody saw this press and was like, oh my God, VR's here now. And everybody's like, okay, how are we going to do the manufacturing? What are we going to do all of this? And I'm like, slow down. This has support for exactly one game right now. It hasn't shipped yet. And it can't play 3D movies. It doesn't have support for any of this other stuff. This is not a consumer device. So, a little worried about all of that going on, but Palmer went ahead and he launched his Kickstarter. So, yes, the days are blurring a little bit together, but yesterday, I think, on there, and immediately blew through the target on there. And he managed to, it actually came out at half the price that we were originally expecting, where the original conversation in the forums was $500 kit, build it yourself. The head tracker I was using was listing for like $99 on there, and so it's going to be a $600 thing if you want to be able to actually use it as a head-tracked system on there. But he managed to get all the parts sourced in such a way that selling $300 assembled kits, and he's getting a lot of orders for them. So it's in the... I'm still afraid that there's going to be a bunch of people disappointed with this, that people see an article, see a head-mounted display, see somebody saying, my God, it was so amazingly cool, and they say, I want one. But there's a lot... The print's not even fine, but people are just skipping right past it. If you have to ask... a question about the capabilities of this, you probably don't want it. This is for people that, that are comfortable being on the very bleeding edge, helping to make something happen. And I was saying specifically, like, the people that do case mods at QuakeCon, this is the crowd that you want building one of these things, figuring out what the right head mounting arrangement is, because this is still not worked out. We've got my ski mask strap. Palmer's got two or three other things with him here, and I doubt we've hit the perfect arrangement on any of this yet. The current one mashes onto your face, and you sweat into it, and you want a little bit more standoff, and pinches your nose too much. And there's a lot of user factor stuff that you don't need to have a chip fab in your backyard to make a real relevant contribution to what's going to be affecting usability and ergonomics in sort of the emergence of the virtual reality. And I do think this is happening right now. I think people are going to look back and say that, the tail end of 2012 is when things took off, because it is now not something that you have to convince yourself is cool like the previous generations of head-mounted displays. This is actually neat to show people. And what people can do with this as you start building what's exciting is all the things that, as I talked about tablets and touch devices earlier, there's going to be a language that has to be developed for how you interact in virtual reality. What's different about a game when you do it as a VR game rather than a thumbstick game versus a touch game versus a mouse and keyboard game? And this is stuff that just needs to be experimented with and tried. And this is stuff that people can hack together. You can work on open source projects and learn a lot of this. So we can learn the language of interaction in VR like we have with touch. Now, a lot of this will change as we get camera output on there, but even just figuring out the right ways you interact with a controller, what you do with menus in there, and to be blunt about the Doom 3 support, where yes, we have support for the weapons decoupled, the view warping is all corrected, but I'm not going to tell you that we've cleaned up the entire game to be perfectly playable through here. The menu systems and the HUDs are not visible directly in this. The cinematics don't have the right field of view on here, but by gosh, you can go to a level and play it in virtual reality, and it's pretty damn cool. But that's the level of what we're talking about here. This is not a consumer product that you go buy as a present for someone. This is an experimenter's kit where you can really be at the forefront of something that I think is going to be a very big deal in the coming years here. So I'm a little bit jittery now that things might be spiraling a little bit out of control, and after this goes off, I'm sure there are 5 companies busy in China preparing their versions of this that are going to come out into the market with some bundled whatnot, and it's going to be great in the long run because there's no reason these will cost more than cell phones. Really, when you wind up, you'll have the whole range of things from low end to high end on there. We'll look at self-contained versus running off of PCs. All of this stuff will get sorted out, but it's going to be a little bit awkward in the coming year or so as there's very little software support for it. But it's so cool when it's working, but there's not a lot of breadth to what you can do with it. But again, everybody should take a look at this because what we had, the response from the people that played it, it ranged from enthusiastic to really awestruck. For some people, this just pushed the button saying, this is what I always wanted to see in here. This is what I thought it should be like. But then there are some people that's like, yeah, this is pretty neat. It's not, they didn't have, they weren't waiting for the VR experience there. So it's something that definitely is making an impact on some people that is greater than any other hardware device that we've really got to play with. So I've actually gone already over the time. Let me look at my notes and see what topics I promised I would talk about and didn't. Graphics-wise, one thing that working with the gigantic pixels on the Rift really makes you appreciate is all of the picky issues of aliasing. And that's something that we saw this when we were doing the iOS games with Rage, when we had a game rendering at 640, 480 blown up onto a big screen TV. And we're like, ooh, there's lots of stuff you just don't, you get away with a lot of sloppy work on modern systems when cracks don't mean nearly as much when you're rendering at 1080p or something on there. But in this case, with the Rift on there, the pixels are gigantic, and aliasing is a pretty big deal. So on the PC, it's not that many pixels, 1280 by 800. You can render that at 4x AA and get a good job out of that. But one of the things that I wish that I could do, this comes down into that graphics geekery stuff that I don't think actually makes much of a difference for a traditional game played on a traditional output device. But I've at least convinced myself that going ahead and doing everything perfectly gamma corrected through all the anti-aliasing stages will make more of a difference in the VR side of things. Because one thing you can notice in Doom 3 when you're playing on this, even in the regular game, is some of the things that in-surface aliasing, because we wind up doing all of the bilinear interpolation of the diffuse maps and the specular calculations, where ideally you'd really want to calculate all of those at fixed forward points and just have a bilinearly gamma-corrected interpolation that happens going to screen space. But there's stuff that can be done, because you'd ideally, in a low-resolution thing, you at least want the world to be absolutely solid. No speckles, no anything. It's a little bit fuzzy because it's blurry, but if it's all nicely anti-aliased and you've got the proper support kernels around everything, your mind will buy that as, well, you've just got foggy glasses, but you're still looking out into a world, while all the little twinkling and distracting things are still problematic. And there are, unfortunately, some content stuff that's kind of hard to get around, like when you have a very strong contrasty thing at the very edge of the texture and the geometry at the same time. The current anti-aliasing stuff just doesn't do a really great job with that. You can kill it with just massive oversampling, and that's one of the things that I did when I was playing with the earlier versions in my R&D testbed is go ahead and start rendering these enormous, 2K plus resolutions, sample everything down, and just get a very, very nice blurry image. And I think that you pay more attention to graphical flaws in virtual reality when you're trying to buy it as reality than you do on a screen when you might be trying to buy it as a cartoon. So I think there may be some hope for the unrepentant high-end graphics geeks to contribute some real value still there. And I should probably talk some about ray tracing, which has come up in several past years. I've mentioned before that all of our offline work migrated to ray tracing from GPU acceleration, and don't look back at all on that, where you give up a lot of theoretical performance, but everything is so much more reliable. There's two factors to that. One, not having the graphics driver doing its stuff outside of our control on there, which was amazingly problematic. I mean, you wouldn't think that it should be, that you have a render farm with 15 GPUs on there, and one of them is doing something a little different for God knows what reason. The CPU stuff is just always repeatable, it's always good, and when you can throw 24 threads on a single cheap box at it, it's not that much slower, and you wind up doing things algorithmically that are pleasant to do on a CPU that are extremely unpleasant to do on a GPU. We are approaching the time when you can render real-time ray tracing. You can do simple demo worlds where a couple years ago I made a 60 frames per second 720p real-time ray traced demo. It would have to sparsely update some of the pixels in areas that were challenging on there, but it would still work, and I'm sure if I did it right now, that same scene could work no problem. But the problem is there's a long way from that sort of techie demo of, look, I'm running around in this world in a ray-traced world going 60 frames per second, to something where you say, okay, I'm running around in Rage or Doom. Those are much, much more challenging when you start bringing in the animated characters and the other dynamic geometry, and you want to have all the multipass blending effects, which all these things you can do better in ray tracing, but it just does mean that while it seems like we're tantalizingly close now because you can do a real-time ray tracing demo, we're still not that close to being able to replace what we do in regular games. But it'll be a good day when we can. There was a pithy comment I saw on Twitter about somebody looking at the new Real-Time Shadows book, where it's a thick tome about all different real-time shadow algorithms. And somebody that's from an offline rendering world just made the comment that, if you need a book that thick to do shadows, you're doing it wrong. And there's a lot of truth to that. Ray tracing, it just works the way you want it to on there, while we are working through big, thick books like that on the approximations that we make in rasterization. But I also am... There's this enticing possibility for the ray tracing that if it could tie in with much lower latency output displays, like I would love to be able to ray trace exactly as the raster is going. If the raster is scanning or whatever is actually scanning it out on there, if I could say, okay, I'm going to ray trace this pixel right before they're integrating the head tracking continuously on there. And while that's, I could do that in a toy level. I could take my R&D test level, that little chunk of Rage that I can ray trace in real time on there, and I was actually pestering NVIDIA, can I get a scanline output counter? It's like I can look on a Nintendo DS or something, you can read, here's what scanline I am on, and you can do calculations on there. That's the stuff we lose in the PC space, that distance from the hardware. I was still tempted to do a demo, just latching VSync, which you can get within, unfortunately, plus or minus a millisecond or so on there, and just predicting ahead, assuming a constant timer clock, doing that type of calculation, pre-warping the world around there. But that's incredibly enticing on ray tracing if you could update in lots of different places in different temporal orders on there. So that's also interesting, but we're still a ways off from being able to replace rasterization with ray tracing. WebGL and OpenGL in general, it's been... OpenGL is clearly just celebrated its 20th anniversary. I regret not actually being able to get in time to put my 2-cent quote in with the celebration for the 20th anniversary there, because it's obviously been important for a lot of what we've done over the years, and I'm very proud of the role that I played in it might not be too strong to say keeping OpenGL alive and relevant in a lot of ways, because there were the dark years when D3D was trying to absolutely kill OpenGL, but we're in a resurgence of all of that now with OpenGL ES on mobile platforms and WebGL and GL being used on consoles, and it's a healthy ecosystem right now. In many ways, it's primitive, archaic, unpleasant API to use. It was better than anything available at the time, but that time was 20 years ago. OpenGL was a refresh of Iris GL there. It cleaned a bunch of stuff up. OpenGL ES actually was a pleasant refresh of OpenGL. Got rid of a lot of the really old cruft, but I don't even know how the driver writers support the current code base with hundreds of extensions that interact in different ways that may be enabled. I mean, that's got to be a nightmare situation, and the fact that some of them can actually work out quite well while supporting all of that is really quite a testament to their engineering there. I know in my shoes, I'd be like, burn it all down, give me the clean, simple, minimum spec, and everybody else, we don't care that much. But that's not the way you actually have a successful business in doing all of that. So they missed their chance relatively recently to go ahead and do a major rethink. They basically chickened out. The ARB couldn't agree to leave some legacy stuff behind. There, that time's coming up again, thinking about it on here, where in many ways, Microsoft's done a lot of great stuff with D3D. I mean, it's funny how it's mostly wearing off now, but for the longest time, Microsoft was never looked upon as, they were always the blue screen of death and DOS and all of these bad things. But Microsoft actually does a lot of really good quality engineering in a lot of areas. They've got good research program. They do good work on a lot of the D3D stuff. They have they do excellent work in software analysis and security, and they've got a lot of really good people working there. So it was, in the early days, it was, yay, OpenGL, this D3D stuff is crap, but it stopped being crap as they fixed it, and it's probably better than OpenGL in most ways right now. But the extension mechanism is still important. That was something that's worked out really great for Rage. We got 2 extensions pushed through that are actually important, that will make a difference to a lot of people doing this type of stuff. There was the swap tear extension, which we lobbied on. The best way to make a case for something is with an existence proof. So we had Rage running on the consoles where we say, okay, we're 60 frames per second whenever we possibly can. If we miss a little bit, we resolution scale down and we back correct for the next frame. But what we want to have happen there is we'd rather get a little tear line at the top of the screen as we overshoot there and then go back to VSync there rather than drop from 60 frames per second to 30. On the PC, you only had the option of either VSync always, where 60 hertz just doesn't make sense with VSync on a PC in that case, because miss a little bit, you fall to 30 and it's awful, or swap tear. And tearing is one of those things that it drives me nuts that we'll have people that will talk about, the crazy do everything gamma correct, add your film grain, do all this skin shader stuff, and all this crazy sophisticated stuff, and then have this big tear line dancing all over the screen. That just does not that's blinding yourself to the environment around you, and I'm very happy that the swap tear extension got through and people can start using that in general. So lock to 60 when you can, tear if you can't. And then the other thing that we got through was the direct texture access extension with Intel, which is what, again, we show on the consoles. Look, we know what we're doing. We've got sinks and fences. We don't update something when this is in flight. We just make sure that, look, we want a pointer. We want to be able to say not text sub-image for every little 1-by-1 page table update and all these blocks. They're just pointers to memory. We will go set them, and we take full responsibility for what we're doing. And this took pulling teeth to get something like this out, and Intel was the one that, my argument to Intel was that this is something that unified memory architectures win at. This is just, it is the same memory. The CPU can access it the same way. We don't have to worry about GART ranges and AGP mappings and tiling regions on the chip of the off card, the card out there. And they can still make the stuff work in there, but it's a no-brainer for a unified memory chip. And unified memory is going to win. I mean, the days of the monster GPU card being a significant fraction of the user base are dwindling. Unified memory, just the economics of it will dictate it. It will win eventually in 99% of the cases. Well, when you count mobile, it probably already is in almost those number of cases. So direct texture access is important. Nobody wants to talk about their texture swizzle formats, but eventually enough tooth pulling, and we got linear format exposed on there, and hopefully that will be picked up in additional places. So the extension mechanism still works. It still has value there. We were able to deliver some real value to the ecosystem, where doing that for D3D would be a much bigger challenge. You would have to go through a whole Microsoft cycle and all the arguments around that. Now, WebGL, coming off of that, is, when I first got asked about that, I was like, well, what? I don't see us really using this on anything. It's another one of these weird, do something in a web browser. And, we were doing this with Quake Live. It's like, oh, you're playing your game in a web browser. That was a plug-in. And a lot of people latched onto that aspect, which was never really the point of it. And in hindsight, we wish Quake Live wasn't in the browser, because it causes us, maintaining that environment has really kind of sucked. And it's been problematic, and it doesn't really offer you much value. You want to just go full screen. But so WebGL as an ability to do 3D content in there is somewhat interesting as a platform, but it's tempered by the idea of using. It was bad enough doing mobile work coding in Java. I had fun doing the Orcs and Elves and Doom RPG and that stuff on the mobile platforms, but there is a sense of strange futility to optimizing Java bytecode. Knowing that you're okay, I'm doing good quality optimizing work that's then going to be interpreted by a virtual machine. And yes, you get just-in-time compilation and all this, but it's not the same as programming directly to the metal, or even just to the instruction set for that matter. And web applications, where you say, oh, okay, no, we're going to use JavaScript. That's taking the absurdity one level further. It's like, okay, we're going to do some kind of high-performance graphics application in JavaScript. This is just offensively wrong on some levels, but I have to temper that with the fact that so much of the magical stuff that happens through offensively bad code on there. All the magic that runs the web is scary, scary stuff, and it's not how an optimizing-oriented programmer would have done things. So I have to temper that by saying there is an initial sense of violent revulsion, but that doesn't mean it's not a potentially valuable platform. And the idea of being able to render interesting content there is interesting, but you still have to manage your loads and all of that. And as it stands, I would think that in general, cloud gaming or cloud applications in general have a lot more chance of delivering real value to people than the web platform. Because our experience with Quake Live, with the web as a platform, it sucks. Every revision of a browser comes out, something breaks, we have to go in and figure out what's different about the environment there. Now, if you have to do something inside a browser, native client is much more interesting as something that, it started out as a really pretty darn clever x86 32-bit hack on the way that they could sandbox all of this in user mode, interestingly, and it's now dynamic recompilation stuff, but it's something that you program in C or C++, and it compiles down to something that's going to be not your -04 optimization level for completely native code, but pretty damn close to native code, and you can do all of your evil pointer chasing stuff, that whatever you want to do as a to-the-metal game developer. But you still have to talk with the rest of the system through the web platform. And the platform specification is still really not good. Over the last 2 decades, we've seen lots of platforms, and platforms are very rarely what you want. Hopefully they evolve to what you want eventually. But going through WebGL, marshalling everything, there's a bunch of inefficiency there, but of course it's still way, way better than doing something in JavaScript. But it does bring up the whole scary issue of security is something that people should be caring a bit about now. In the old days, when we're at graphics performance, where just making our graphics do what we want is, get to an acceptable level was the critical goal. But now, graphics is, in many, many ways, good enough. And I don't actually think it's a good idea at all to sacrifice security in something that might be used regularly, like a browser, for some degree of graphics performance. So I absolutely believe that the marshalling that goes on through the WebGL interface is the right thing to do. And it still scares the heck out of me, because just no one with a straight face could try to tell you that a WebGL application is fully sandboxed, that I just don't believe it for a second. We're constantly seeing people break out of sandboxes involving just the CPU, and everybody that's a graphics programmer has at some point crashed a GPU in some way by sending down some fragment program combined with some set of attributes. It's just not the most stable system. They're getting a ton better. I mean, we have finally, after a decade of me whining about it, we have virtualized resources on the GPUs. We finally have partially resident textures. I think John Paul is actually doing a talk with AMD at SIGGRAPH about some of the work that we've done with that. And I've literally been looking for this for over a decade. I was asking for this while 3DFX was still around, and I think it made sense even all the way back then. It's been very, very frustrating how we can have some stuff that takes off like a shot here, like the head-mounted display stuff, and then we can have things that I know I was right a decade ago on this, and I was right 5 years ago on this, and we've only just now finally gotten this together. It would have been better for consumers, graphics developers, board vendors. It would have been the right thing, and there are socio-cultural engineering issues with hardware developers that made that much, much harder than it should have been on there. I almost got my, a couple years earlier, it looked like I had finally convinced Apple that this was the right thing to do, that especially when you've got backed by Flash on here, this makes all the sense in the world. And it looked like the Imagination Technologies GPUs in there had page tables. They had them there for a while. Nobody was using them. And it looked like it was going to work out. We were going to get this. We were going to show everybody on the mobile platform. But it turned out like the latest rev of the chipset, nobody was using this feature, and it broke, and nobody noticed, which made me very, very sad, because that means that it's not coming to iOS for a couple more generations at least before they could write something like that off. But so, virtualization of all of that's great, but still the GPUs are pretty scary in terms of what they may do all around memory, or what they may do and just peeking at other parts of the memory buffers on there. And it comes, again, back to the size of the OpenGL drivers, they terrify me. They're just, as a software engineer that looks at lots of code, sees lots of bugs and problems, the scope of that code base and the interactions is really, really scary. And to think that that is going to be exposed to random web page content, that does not yet strike me as a particularly good idea. So I would favor completely remote streaming, where people find holes in video streamers still, and that's this nice compilation. You fit that in one function file. You look through all of this and say, okay, there's a lot of scary stuff going on here, but I can chase through all of this. I can analyze it, and I probably only missed a half dozen things. Looking at an OpenGL driver and saying, okay, we're only going through the ES profile, and we've got our robustness set up on there to validate everything. But still, that's scary, terrifying, trying to say that you want that, that you think that's actually going to be safe. I mean, they should do something like, if you really want to stand behind that, make a public share of some of your sensitive internal data protected by the OpenGL sandbox on there, and just see what happens. Because I don't think that if money and risk really had to go where they're saying it should go, I don't think too many people, I'd be interested to put that question to their engineers, but I don't think that they would take that bet on there of putting something that critical in the path of the driver there. It's just too complicated, and I don't know where to get to that point. A clean room implementation of the limited subset on there would probably be a good idea, but it's still a scary thing. Somebody asked about different CPU architectures like x86 versus PowerPC and ARM or x64. And that's something that it was interesting how in the early years, up through Quake, I cared a whole lot about CPUs. As we were going from 8086 to 286, getting our 16-bit, getting our protected modes, extended memories. When we started getting 32-bit protected mode on there, when we got floating point processing. Those were critically important things that made fundamental differences in how we wrote code and what we targeted on there. It's been diminishing in importance ever since. MMX on, all of the different SIMD extensions. We take advantage of all of them. We have lots of SIMD code that makes differences. It makes modest differences in the total performance. When you look at kernels, you're like, wow, this rocks. This is 4 times faster. But when you integrate it over the whole thing on there, it's like, okay, it's helping, but this is no huge world beater like we had on some of the earlier transitions. But for the most part, since then, CPU architecture hasn't mattered all that much. We compile everything for all of the architectures on there. The big difference is between in-order architectures like the current console power PCs and out-of-order programmer-friendly in-order cores. Simple in-order cores are optimizer-friendly. Out-of-order cores that are superscalar, have prefetchers, and do all this stuff are very just kind of normal programming-friendly. And you get that case where it's great fun to go ahead and have something on a current console and say, this is too slow. I'm going to go in, I'm going to write better code, and it's going to double in speed or triple or quadruple. And you can go in and expect to go make those kind of differences there. When you say, this code was written, it's too slow, I'm going to go make it faster. Current x86 processors can be frustratingly difficult to make real differences on. There's plenty of occasions where you have code, this is too slow. I'm going to completely redo all of this, change the tiling order, and prefetch this, and you get 5% faster with code that's twice as ugly and took you a bunch of time to write. There's a lot to be said for making programmers' lives easier, and Intel has done that year after year. They just get better. The processors are better and better, and our code gets faster and faster, and we don't have to do anything about it. The consoles have been great for optimizers, where it was probably the right decision this generation. Give us more cores, make us sweat a little bit for it, but there's definitely a cliff there where my personal opinion is that the cell processors in the PS3 stepped one step too far there in that they were, it was an optimizer's dream on there, but it was that step more inconvenient for the lack of direct virtual addressing or direct caching and everything. So it was awkward on there and painful, and you don't like doing a whole bunch of stuff there. But the ARM chips are somewhat in between there, where as an architecture, they tend more towards the x86 side of things, where you can have superscalar ones, you can have out of order. You wind up, in the uses of ARMs, the mobile platforms, you wind up being gated mostly by memory bandwidth. So you care a lot more about that than a lot of twitchy CPU optimizations on there. But they're great, they're fine. There's no CPU instruction set architecture that I actually care that much about one way or the other. It's not that exciting. There was a time when I would be excited about instruction set architectures, and I know when we were talking about Larrabee at the Intel people, and I was kind of like, yeah, instruction sets, SIMD, 8 wide, yeah, whatever. And let's talk about the system level architecture things, how the SIMT stuff is set up and all that. That was much more important. So I still don't care that much about instruction sets. 64-bit, we are at the very trailing edge of anything 32-bit relevant, so it's going to be interesting to see how ARM makes that transition. Obviously, we're fine on x64 and PowerPC there. So it is interesting to see whether my suspicion is that GPUs have also stepped past that line of doesn't matter that much anymore, where up through DX9 was like the step up through floating point in CPUs, where each step was important. It made a real difference. You changed the way you did things based on this. After that, it's more like SIMD, getting DX10, DX11 class stuff. Yeah, you can do neat new stuff on here, but you don't require that to take the next step in what you're doing. Just more of the same is winding up being what 99% of the people wind up using anyways. Windows 8 adoption. At id, we stuck with Windows XP till the bitter end almost. We had almost nobody using Vista. And then we got to Windows 7, and everybody switched to Windows 7 on there. At this point, I don't think anyone is running Windows 8. We obviously should be testing that with Doom 3 right now, considering the product's coming out contemporaneously with that. As I said earlier, I actually have a good deal more respect for Microsoft than many in the sort of hacker enthusiast community do. I have perhaps less. I have less comfort that changes in the UI paradigm are going to come off well, but I have no dog in that fight. I'm kind of excited to see a Surface tablet. Robert Duffy is trying to use a Windows phone for a month on here. It's all worth doing taking a good look at, but I'd be completely happy if Windows 8 didn't exist and we didn't even have to face this problem, because I'm pretty darn happy with Windows 7. There's really nothing that I'm looking forward to in Windows 8. As an OS, for the most part, Windows XP did what I wanted on there, and I haven't cared that much. And seeing that theme on a whole bunch of things here, where it was a huge difference as we went from Windows 3.1 to Windows 95 to Windows NT to Windows XP. Those were differences that mattered, and I think we're past that point of, okay, the differences just aren't mattering that much anymore. We need to keep it for hardware updates, and Windows 7 did have actually substantially better, surprisingly good virtual memory management performance on some things. There's some debugging stuff that we do with mapping scads of pages, and I did something with a terabyte of virtual memory set up over different things, and Windows 7 is doing a lot better than XP. Things I wasn't even aware that they had improved on were suddenly, in some cases, hundreds of times faster under these heavy load conditions. So that's all pleasant, but there's not a single thing that I'm salivating waiting for in the next operating system. In other I/O devices, one thing that audio is, in many cases, we can look at as essentially a solved problem right now, where we've been down the road twice of doing sophisticated audio processing, and we regretted it each time, and there's still a push like, well, let's go try it again. The difference between presentation of the very best audio processing versus just adequate audio processing will not turn a B level or even an A- sound designer's work to be something better than a top-notch sound designer's work. We really are in the land where it is driven by the quality of the media, and there's just not that much that code is going to be able to do to improve that. Now, I have, for the first time in years, as I was doing the VR stuff, I have a little bit of an itch to go do a little bit better job on the head modeling and proper tracking on there, where for games, we're assuming that you've got speakers or maybe 5.1 surround sound. It's a small fraction of the people that have headphones. In any case, they don't have head trackers on there. But when you're in the head tracked system with earphones on there and you're looking around, I can buy that it would be really worthwhile to go ahead and do the phase modeling, do the room modeling, and the head transfer function on there, because with the head tracker, I think it makes a difference. I don't think it's worth it for a static viewer on there, where any subtle movements that you're doing are actually doing exactly the wrong thing for what your system is doing. And those subtle movements are important for your eyesight. I can definitively show that with the VR work. I suspect that it's similarly important for the audio side. This is all solved work. People have done all of this before, and I think that's something that's worth picking up. I'm not going to have time to in this go-round, but maybe by the time the next project comes around, we'll be able to integrate that, because I have a desire to see that in there, and it will probably make quite a good difference. I suspect similar to the positional tracking in the visual side of things. One of the I/O devices that we'd really like to see, and I don't see any great ways to it, is better force feedback in some way, where for years I have been making this pitch that it doesn't matter what we're drawing on the screen nearly as much as what we change in I/O. I looked at the Wii and the Move and the Kinect and all of this as steps signs that changing the I/O equation is actually more important, and I think the VR side of things really convincingly shows that, where this cobbled together piece really does show something. So I/O devices are probably where the big movers are going to be. It's not going to be a great new graphics algorithm or a hyper-powerful GPU. Changes in the way that we interact with our software is what's going to make things really, really change. But I have no good idea on how to do that with tactile feedback on there. And of course, when you start getting into exciting tactile feedback, you get into dangerous tactile feedback. And if you've got something that can actually manipulate a person in some way, it's dangerous. And I look at, at Armadillo, I would look at boxes of old, outmoded linear actuators we don't use anymore, and I think, I should take those in a driver board and make some kind of little ride for my son to play around on that I can drive by the computer. Because it still does matter. Like, there's a difference between if you go to Disney World or something and you ride the big rides that are swinging you around and having these extra effects on you, the gusts of wind and the changes in things that are not just optical. It does matter. There is still something to be done there. But until we get to direct retinal or direct neural stimulation on there, the limited cases, whether we can do something with gloves, I'm not a big fan of gloves. Other things that we can do with controllers. Rumble was a nice, trivial addition that we had in there. There may be other modest things that can be done there. Certainly, I hope on touchpads we wind up getting some level of tactile feedback that's better, but I'm not sure exactly what's going to happen with that. On displays, going over the size, resolution. Resolution is worth talking about a little bit on the limits of what matters there. So Apple makes a big deal about the Retina displays. You hold your iPhone out and you say that this is the limit of what the eye can perceive. And there's actually fudge room there when you're talking about phase offsets about what you're looking at, but it's ballpark enough correct that you can talk about that. But you look and say, well, I want a virtual reality that encompasses me, that has that same level of resolution. So you hold out your iPhone there, you say, well, how many iPhone screens does that take to tile my world like that? And it's a lot. It's an impractically large number, even when we're talking about these crazy high resolutions here. But the potentially positive side of that is how little your eye actually cares about that. Because here's an experiment. It's like, take your smartphone out, get it at a point where you can read a word in there, and then try, without moving your eye, to read something at the top or bottom of the display. You generally can't, because your actual foveal area of interest is only a couple hundred pixels in diameter. You only care about this very tiny amount that is this level of resolution. Everything else could be 1/10 the resolution. We actually have enough bandwidth on current display cables, if we could send exactly the pixels we want, to satisfy the optic nerve on there, essentially. If we could have a low-resolution image projected over everything and then the tight focused region right where you're looking, we could do that with the graphics processing power today, with the bandwidth that we've got today, but no one has yet developed a really good solution that can do accurate tracking. We've got tracking solutions, but figuring out how to actually make a display that can position this hotspot in different areas like that is actually not a solved problem. There's thoughts of doing that with laser scanning, different things like that, but there's some fundamental challenges at the upper resolution end that are material science limited with the laser scanners. So there may be some other scanning technology that can wind up working, that can let you draw it out in vector patterns where you spiral around from the point, having a spiral raster scan that increases in density or is tight and then goes to a much lower rate. We can imagine things like that would allow us, with the computing power that we've got today, to render a world that has the perceived resolution of everything around us. So hopefully that's one of those, we wait for a breakthrough. We wait for something that can resolve that. We don't have to hold up immersive VR waiting for that breakthrough, but when it happens, it'll be a dramatic change on there. It will have big effects. We might wind up seeing that focusing, that type of focal region as strictly a bandwidth compression mitigation measure there, where if we talk about this display that might have a 1920 display per eye plus the two cameras looking out at that, and you've only got one Thunderbolt's worth of bandwidth on there, but you want to update it at 120 hertz, then maybe you do wind up tracking a foveal region on there and only sending that at the full resolution and sending the rest of it at a lower resolution and letting that be blurrier, because we today can make displays with more resolution than we have bandwidth that we can easily transmit to it. Then brief update on Armadillo Aerospace to close it off for questions for anybody remaining. So it has been pretty sad for me that I haven't been able to be as involved as I used to be on there. I have been really consumed with all the software side of things and 2 kids now, and I get over to Armadillo just rarely now. I was supposed to be over there last Saturday doing the final setup for our next launch on here, where I go in and make all the final code changes for everything that we need to have on there. We are within a month of launching. The last flight went to about 95 kilometers, so we were grabbing space. We were right up there on that, but had a recovery failure, so it made a very expensive hole in the ground. The next vehicle that's pretty much together now. It's bigger. It's 20-inch diameter, 30 feet long or so. You can actually crouch down and get inside the payload compartment if somebody wanted to on there. Richard Garriott, Lord British, was actually in line saying he wanted to skydive out of the rocket on there, but he just got married and has a child now, so I don't think his wife's going to let him do that anymore. But people are actually interested in doing that. But the real near-term thing is we were just granted a commercial reusable launch vehicle launch license, which is the only one right now for a reusable vehicle. So we can actually take paying customers. All of our previous flights have been under either experimental permits where we could theoretically fly to space, but we couldn't charge any money for it. The Lunar Lander Challenge sidestepped all of that by saying we're not paying for the flight, we're going to give a prize based on the result of this. And the FAA let that slide, but in general, if you want to take money from people for flying stuff, you need a commercial launch license. So we were, again, the pathfinder for that. It will be the first reusable vehicle to fly under a commercial launch license. We were the first to fly under the experimental permit, first to fly under the Level 3 waiver. So we have been the bellwether catching some arrows in our back with all the regulatory processes on there. The vehicle can carry, we're carrying 2 payloads now, I think a Purdue University payload and a European Space Agency payload on the first flight here, paying real money for it. I hope we don't crash. If we get this back and we can fly this regularly, it should become a going business here. It will be, it'd be nice to have a real product to sell rather than trying to be like so many other aerospace companies of trying to get on the contract gravy train of, I just don't want that for the company. I want to have something of value. If you need this, if you want to fly suborbital payloads, here's what we do. We fly on a regular basis. That's where I want to be, hopefully, the end of this year. So within a month, we should have this next flight off. If it works well, hopefully we get it back and we fly it again within a month and build additional copies, fly this more as we work on scaling up again after that while we've got kind of a general revenue stream coming in. So it saddens me that I can't work more on this, but I've got all of these things that, I would like to build more head-mounted displays myself. I would like to work on more software R&D. I'd love to do the visual optical flow velocity tracking stuff on there, but there's just not enough hours in the day, and I have to, I do have to make the top development priority the big software projects at id. But I get some time here and there to work on the different things, and it's all still rewarding. It's a good mix of things. So everybody that's still left, I can take questions for a while longer. I'm surprised my voice hasn't given out here. I figured I was going to lose it after an hour or so. It'll be tomorrow. I'll be croaking for all the interviews. But do we have a microphone anywhere in here? Somebody? Okay, well, I can take.
I don't know if it's on. Oh, yeah. So you mentioned earlier about Rage that you had an uncompressed, totally uncompressed level area, and you said you wish you could ship the game that way, but obviously, 1 terabyte's not an option. And as someone familiar with the algorithms involved, my biggest disappointment was finding out it wasn't going to be a 300 gig download from Steam. And we hear a lot about, OnLive and how they could do more than you could do with your local desktop. And I see no reason why you couldn't have, high-speed storage supporting 300-400 gaming incidences in the server, and I think that'd be a really interesting.
So it's actually better than that in that so there were a couple things regarding the textile density in Rage that we had made the decision early on to have a consistent textile density, which may have been a mistake even in the early case where the thinking is that we saw this some in Doom 3 and really badly in enemy territory where if you have a texture that's stretched out really low res and then you have a high res something on top of it, it doesn't look right. It doesn't feel consistent on there. So we uniformly clamped the textile density in Rage. What we can do now that we have the detail extrapolation stuff, we can say, well, everything's got 4 times the resolution, and it'll be real resolution for the things that we care about, the stuff on the desk, your paraphernalia that you want to look at, and it'll be fake extrapolated detail for all the rest of the acreage that we're not actually transmitting at that resolution. So that will help, but it actually works. The early tests that we did years ago didn't really follow up on it, but if we use the same prioritization algorithms that we do for all of this smart scheduling of stuff, trying to deal with Blu-ray latencies of like 150 milliseconds to seek over there. It works really well over a network without us even trying very hard to optimize for that. We are at least considering trying to make an optimized network streaming thread that knows that everything is equally fast to get. So you schedule things and you have a lot of them outstanding because you can have a lot of bandwidth actually in a 50 or 80 millisecond delay there. You can have a lot of bytes coming down, a lot of different pages. Instead of pulling them in pages at a time, disk pages at a time, like 128K at a time, you would actually individually cache the 128 by 128 graphics pages. And I know we could do quite well, and I suspect we might even be able to do remarkably well with a decent connection there and having it cached through the same cases locally. I joked about it in years past on there, but I was at least somewhat serious that you could make like an MMO that had the entire world textured with a petabyte of, you could throw literally a petabyte of surface data at it. You'd have challenges rendering all of that, but you set up all sorts of cloud instances and work through that, and it's doable there, and I think it would be pretty compelling, but that gets into scary technical risk stuff on here where we do feel a little bit burned by how long it took to mature all of this technology, but that is the type of thing that setting up network streaming for arbitrary quality downloads, I hope we get that in the upcoming products because that is on our radar. It is sensible, it's a good fit, and it will deliver real value. It's not a guarantee right now, but technically it appears to be plenty feasible, and I definitely want to go down that road. Yep.
My question is that it seems like in the past you've been a champion of low latency gaming as something equal in experience to, say, resolution or texture quality and enhancing the gamer's experience. Do you think it would be a worthwhile thing to create an open standard for low latency devices so that maybe a logo on the box could allow an enthusiast gamer to vote with their dollars about that experience?
So I have some hope I've kicked a bunch of companies with that notion that HDMI should have a low latency bit in the bit stream on there saying, please do not do any processing on here that involves buffering. And that seems to maybe have a little bit of traction, but the display industry it takes a while for all of that to go through. That's, again, one of those cases where if the displays were sort of like OpenGL, we would define an extension, like for the swap interval thing, and say, low latency, please. And some display vendors that supported that could just start looking for that. Everyone else would ignore it, and that would be a wonderful thing, but we don't have that sort of infrastructure in place. So likely that's something that takes years to happen. I mean, I hope it doesn't take a decade like virtual texturing on there, but it's at least on some people's radar. And I think that I have been harping on about this a lot, and I'm going to be doing yet more of it with the VR stuff as it goes on. So it's at least coming to a lot more people's attention now, both reducing the latency and increasing the scan out rate. So I have things will get better. They won't get better as fast as we would like them to.
Hi. I had heard rumors that you were working on non-polygonal rendering. So obviously, instead of making several points to create something that looks like a sphere, but rather actually rendering a true sphere.
Okay, yeah, so there's a couple directions that I have spent a little bit of effort on in there. Analytic rasterization of higher order surfaces, spheres or NURBS or whatever, I think that's a completely losing proposition. Because adding extra smoothness, as we find over and over again, just really doesn't add that much to the quality. We've done those cases just recently where you add 10 times the smoothness to something and it just doesn't make a damn bit of difference. But adding huge amounts of interesting detail, like with the sparse voxel octree stuff, ray tracing into that, and I actually think that there's it's somewhat more plausible to do a splatting architecture on current generation hardware, where instead of tracing in, you go to an old painter's algorithm or alpha saturate on there and just render, you plow through your entire couple hundred megs of data set on there, and you're just managing different MIPS of that. It's an interesting thing, and that actually was something that I was looking at that when I was blowing up one of these iPhone levels onto a giant screen TV and saying, man, that pixel's really annoying. If that was all a fuzzy blob rendered through all of there, this would be blurry but aliasing free on there. And it's an interesting topic, but I don't think that it's going to turn out to be. Polygons have turned out to be so fruitful from a utilization standpoint. And I've said this a few times before, and it's absolutely true, that after 4 decades of research into parallelism and multiprocessor utilization, the vertex fragment paradigm is so far and away the most successful multiprocessing architecture. It's not even close. So discounting vertexes and fragments is probably not a smart bet at this point. Eventually, I do think ray tracing will wind up taking over that, but it'll probably largely be ray tracing against polygons because of the pipeline inertia that everything's going to have by then, or by now even.
So maybe something for IdTech 6 looking far down the line.
Yeah, certainly not analytic surface rasterization, and I'm a little bit down on the value that we're going to get out of all of the extra stuff there. But yes, the next step as we do some other big thing would be virtualizing the geometry in some way, but it's still going to be authored as polygons. Even if we rasterized it to voxels or to splats or something, it's going to be built in tools that build polygons, and that's just, there's almost zero chance that that's not going to be the case.
Okay. Thank you.
So I think, first of all, we all want to really thank you, for this presentation. It's been really interesting. But so going back to the beginning of your presentation, my question is, you talked a lot about the product development or technological pipeline, in development. But from like a purely human organizational perspective, do you see it moving towards like agile development, or do you think that would ruin the culture of a video game company?
So, I'm the last person to really be asked to expound upon social cultural factors in the company because I'm horribly tone deaf to so many factors that just a lot of people take for granted. And we've had plenty of problems at id over the years and still do to various degrees with being able to get a team to really everybody pull in the right direction and everybody pitch in and do the right thing in all cases. So we don't have any kind of a silver bullet for that. We still struggle with a lot of those issues. I don't think I'm the man to solve any of those things. I have to hope that that other people in the company step up and take the the leadership role of getting everyone to rally around them. And that was, there's value in a lot of the non-technical things. I go on and on and on about the technical stuff because that's who I am and what I do. But that's not to say that that these are even the most important things. Maybe not even the top 2 on there. Technology is necessary. But the value that we derive from the stuff nowadays comes from all of these other factors. And I'd like Matt Hooper to be doing more of these things and talking about the larger stuff. It's hard right now when you can't really talk about what we're doing directly, but how the team works. I actually asked about. I proposed going into a bunch of the details about what we've done internally, how teams have changed, what the problems and everything have been, and it was just suggested that I not do that. There really talk about how it's hard to argue with Bethesda's success on there, and there is a Bethesda way of doing it is they don't talk about how the sausage is being made. You just enjoy it when it's all done. So there's a little bit of of a nudge that that hey, let's try and take that this way. But we have issues where we're trying to work through all of them. We just passed a major milestone internally that I hope everybody feels really proud of the work that they've done on that. But we have tried different methodologies and to varying degrees of success. I wish we had a silver bullet, but we don't.
All right, thank you.
Yeah. My question is relating to cross-OS support when it comes to video games. I was wondering if there's any obviously Steam is on Mac and they've made an announcement that they're pushing out to Linux. Do you think that approach is the way going forward as opposed to, say, passing through a graphics card to a virtual machine directly and just having, an integrated card for the host OS and passing your GTX 600 to a VM and having full compatibility that way? Where do you think it's going?
In many ways, the whole virtualization stuff has been a giant failure of operating systems, where in many cases, the fact that we have to have sandboxes below and hypervisors above really means that the classic OS model failed. You're supposed to have, the whole point of an OS is to isolate processes from each other and allow you to run them independently without interference, except for when you opt into doing that. But unfortunately, the notion of a platform involves standard file locations, communications with all of these services, and through neglect, we wound up with this case where the OS alone isn't enough to shield you. You start needing sandboxes, virtual machines, and all these things. And it's really pretty damn unfortunate that you can't expect to have a web browser, that just launches other processes in a completely safe way, because an operating system should be able to deal with all of that. Now, virtualizing platform on top of platform is intellectually interesting in some ways. Emulation of old stuff is great, but it does come down to, again, that it's sort of appalling what we jump through with all of these steps of virtualization, and we shouldn't really have to. I will not be surprised if something that, God knows JavaScript has an immense amount of traction, and in many ways it's accidental. It's certainly not through careful analysis of the merits of something like that. It happened through somewhat accidental factors there, and we're stuck with this situation that it is appalling doing games in JavaScript, doing anything performance intensive. One of the things that I'm really thrilled about is that iOS, I credit to a large degree with saving native code in many ways. We were seeing this point where, as people were going to the common language runtime in .NET, where you're like, only Neanderthals program in C++. But when you got highly interactive mobile devices that were power limited and more limited in memory than the desktops, it was great to see. Of course, they start out saying that, Java is what runs on mobile because it's sandboxed and security. But once you start actually caring about the experience, people found out it's like, actually, writing native code really does matter, and that's still important there. So platform-wise, it is a shame that we don't have that same realization really on the PC web space, that we still do have all of the sandboxes and virtualizations, that we can't have that level of protection there. I guess I have to be a little defeatist and say that probably one of these virtualized things will wind up being a significant, important platform, and I think it's going to be a shame, but it'll probably wind up happening that way. It would be great if the GPU is also through a big wrench in all of that. When you're just talking about CPU virtualization or CPU sandboxing, that's a tractable problem. Until recently, virtualizing a GPU was just not a tractable problem. It was not something that the CPU, you can time slice it up nicely, you can virtualize the memory and throw out pages and remap them, while a GPU, traditionally, you had to swap textures as units in there. You had to do these massive thunks when you would change context and things were at or close to the resource limit. They were never safe. They really probably still aren't safe, although maybe they are. So maybe we're at a point now where everything could be virtualized, but the contexts still don't time slice and share as nicely as you'd want from a CPU side. It's tempting to think that we could have a cloud virtualized platform service where you sign up for a certain amount of GPU, or you share, you use it on demand, and a certain amount of CPU and a certain amount of memory. And it would be nice if that all worked out. It still seems somewhat technically risky on there, not completely solved. Probably will take a fair amount of OS, hypervisor, whatever level work to get all of that to work. It's an interesting question of if we would even want to nail down a platform and program at a low level there. I could see a good world coming out of that, where you might have a platform where here's a low-level GPU instruction set, you can program it as if you've got hardware, but it is fully virtualized. It's certainly technically feasible to consider something like that, and you could avoid most of the overhead of the drivers and a lot of the changing ground underneath you if you virtualized at a lowest level. But I'm not sure. I don't know that things are going that way, and I'd be probably a little surprised if it wound up that way. It may take another decade for the GPUs to get to the point where they really can be split up and scheduled just as easily as the CPUs. But I can be hopeful that there might be some, some additional work in that direction. Next.
When you talked about VR and the holodeck, my problem with the holodeck shows was how come they never ran into a wall when they're just in there? And have you worked out moving within a game? I heard somebody say something about a treadmill with handlebars that would steer you, and that seemed a little silly.
So there's actually been a number of things tried in that way. There have been some interesting research that people have done with subtly changing the space that you're going through, like making hallways so they're not really straight. They actually curve a little bit as you're walking through them. And there have been a lot of papers written about stuff like that. There are a number of devices, like people inside giant balls on rollers and stuff that you could move around. I actually had somebody contact me just last week that I knew from some rocketry stuff a decade ago on there, and said he was involved in some project like that. And I said I was interested but skeptical. It would be nice if something like that happened, because the current VR demo, you can play doing all of the rotating on foot. So you could stand up and rotate 90, rotate 180, and only use the joystick to go forward. And it's kind of interesting when you do that, because your body does have a sense of, I'm back to pointing the way I was before. There is an extra level there. It's a little bit weird just shuffling your feet around there, and if somebody's not managing the cords, you're going to trip on them eventually. But my end game solution for the VR stuff is going to be something wireless, something that uses optical tracking to analyze the space around it, and then you can start saying, well, I'm going to set up a playroom that you can go ahead and skin the playroom in whatever you want on there, and have real world props that go with it that have something else happen in virtual reality. But the whole tactile sensation of actually moving and having the accelerometer sensing for that. Yeah, that's another one of those waiting for a breakthrough type things. I don't think that's a near-term thing. Whether we get that first with some really clever physical thing that is both economical and not dangerous, or we have to wait until we have direct neural stimulation, I don't know.
Thank you.
Yeah.
My question is related to that actually a little bit. Shigeru Miyamoto was discussing in some interviews about the Wii U and using it as a possible virtual reality controller in the manner of holding the controller in front of you like this and then using it to walk around. And his actual theory for that game would have been like an FPS type game. I mean, in his case, you probably wouldn't shoot things, but what's your thought on an interface in that manner, or does something like that sound cool to you?
So we'll probably talk a lot more about augmented reality stuff tomorrow at the panel, but it's fun. My kids like playing the little 3D DSi and Vita games that poke through the world on there. It's interesting. I think that in the long run, augmented reality has more impact than immersive virtual reality, although I think they can both be quite large. I mean, building a simulated world around you that's convincing has a lot of value, but augmenting the real world around you, it's basically giving you a superpower when AR works right. When you start seeing everybody's name and all the information you're supposed to know about them floating over their heads and stuff annotating the world around you, that's going to be great, but it's actually much harder than the immersive VR side of things. Michael should touch on a bunch of those points tomorrow. So I think that I haven't seen anything that I think is a truly awesome game. There's lots of gimmicks for pass-through AR. I'm not sure that something of real value has been developed for that yet. I think there's huge value in AR when it's done really well, but I don't think that we're at that point for something really useful. We can do it pass-through to a good job today, but the appeal of AR is that these would be glasses that you could imagine if somebody nailed the hardware and really got it right. Google Glasses is a vision statement. That's not what people want with their Terminator or Predator vision on there. Google Glasses is a camera, a little window, and some touch stuff on there. The vision statement, though, of having your cyber eyewear that's annotating everything around you, that's going to be immensely huge. You could really imagine everybody that has a smartphone, and you think about it, it's not that many years since smartphones came out. 5 years since the iPhone, and before that, really, the smartphones weren't all that important. And when we look at a 5-year change like that to the point of almost ubiquity inside a demographic like this, you could imagine that happening with AR if the hardware really got nailed. You know, you could see huge penetration numbers of people wearing AR goggles because they would be so valuable in the things that they would provide you. And they'd eventually be fashionable and people would be, proud of what they're wearing on there. So I think that's huge, but the difference is I know exactly what we need to do to get where I want to be on immersive virtual reality. We need to get this, and this solved, and then we've got all this other stuff that we could polish to make better. The AR problem is a lot harder, and I definitely recommend that everybody interested come tomorrow night so we can listen to Michael talk about it.
Thank you.
Hi, my question is that is there any issue about rendering screen space effect with the VR system, such as the particle system?
Sorry, could you say that again?
Is there any issue about rendering screen space effect with the VR system? Something like the particle system with the twice, the user may find the particle is flat, not volumetric, something.
I'm sorry, I can't make out the question.
Like the depth of field effect.
Depth of field? Mm-hmm.
Yeah, and rendering with the VR system.
So we actually disable a lot of the screen effects that happen on there because they are actually bad in a VR space. So things like the head kick is turned off. Some of the 2D screen effects are turned off. Depth of field is a bad thing to have in VR. So a lot of these things that we do for artistic effect in 2D are bad carried around on your head. So those are some of the minor modifications in the game that were made.
Okay. Like the particle system may render the particle by the volume rendering, something like that.
So the particles, you do really notice this. If anybody, when you play through the Doom 3 demo, there are a couple effects, like there's a 2D warping effect, and if you're going through some of the particles, you do notice those standing out as 2D posters on there. So it's not an optimal game for this, but with the gameplay changes that were made were important on just disabling some of these things, breaking the gun weapon away from it. But in fact, that's one point that I did not mention. One of the hardest things with getting both the 3D TV and especially the VR stuff right is figuring out how to position the weapon, because weapon positioning in an FPS is just, it's a huge set of hacks where it's not the weapon in an actual realistic position and the view in a realistic position. You know, we move the weapon around to try and get it to look good and not too foreshortened, but that winds up with it, we've got depth hacks so that the weapon doesn't poke into the rest of the world on there and clip by it, but now that's wrong in 3D and stereoscopic visions. I'm hoping that as we develop Doom 4, that now that we have as soon as we ship Doom 3, I get to bring all this stuff back over into Doom 4, so we can have, from this point in the project, make sure that we position the weapons and we get all these other things done right, because that's one thing that we're just tweaking at the very tail end of Doom 3, because there are some of those factors that the 2D view is not appropriate for the 3D view. I'd like to make everything as realistic as possible, try to say it is a rational 3D world, and at least with the huge field of view that we've got on the Rift, you can have the weapon in a variety of realistic positions. And one of the neat things that happened completely by accident, emergent behavior, when I decoupled the weapon so that you can bring the weapon up or down independent of where you're looking, you find that just naturally, if there's no hostiles around, you drop the weapon to have an unobstructed view, and then when something jumps out, you bring the weapon up kind of directly in front. So I think that we can get away with doing a more realistic weapon holding and position on there, but that's something that's going to wind up getting tweaked through.
Thanks so much.
Okay. Yes. Okay. Yeah.
Hi. I had a second question, but I thought it would be in better taste to wait back in line. You know about the medical technology using neural interface, correct?
So I was actually surprised at when I was in Seattle talking with Valve guys. Gabe brought that up as having seen some impressive stuff recently, and I was surprised because it wasn't really on my radar. I was aware of the early research that was being done there, and I had some vague knowledge of the consumer toys that people are playing with, but it is not something that I'm up to date on, and the impression I got was that it may be a little further along than I was expecting.
So it could be, down the line of course, it could be a very major step towards true virtual reality.
You know, the end game would be that you just directly stimulate the brain. You know, you have the Matrix, and it's not ludicrous to talk about that. We do not have the actuators, you know, the effectors to be able to do a good job on that right now. You know, even with sticking pins into people in all the appropriate places, but it's not something that's constrained by, you know, contradicted by the laws of physics on there. It's not clear how necessarily you externally stimulate nerves that are in bundles and how you tie them, how you tease them apart and address them indirectly. But it would sure be exciting if that works out on there. It would seem that even gross motor things, even if you could do, instead of the force feedback about having big servos that kicking you around on there, I would imagine that it's going to be, before we see direct optical stimulation at the fidelity of the world around us, we'll see things that make it just feel like you're being tilted, pushed, or walking forward or something like that on there. And I have no idea that's the type of thing where wasn't on my radar. I was thinking, maybe this is decades out on there, but it might be something that shows up in 5 years. I really have no idea. It's one of those things I can just be pleasantly excited about when something like that breaks.
Thank you. And as a huge fan, would it be all right if I gave you a t-shirt?
Yeah, sure. And I'll when we wind down here, if anybody has anything else you want signed, and I'll be around for a bit. All right. Yeah, thanks. All right, what do we got? Another one?
Yeah, well, I guess I had a more general question about the internet. It seems like some of the telcos are starting to charge by the gigabyte. Verizon is no longer rolling out a DSL or Fios and is going to 4G where it's $10 a gig. So how's that going to affect gaming in the future? And or is it on the radar screens of the game developers?
So that always gets trotted out when you talk about cloud gaming. Any time somebody talks about OnLive or cloud gaming in general, there will inevitably be comments about how, this can't possibly work with my bandwidth cap on there. And I would just say, this too shall pass. It was modems going away just kind of snuck up on us where we were going through. It's like, okay, we've got our 9600 baud modems and all these awful problems with data compression and error correction on the higher rate modems. And then all of a sudden, everybody has broadband. Yes, it's an issue right now, but there are such strong technical factors that we'll be driving additional bandwidth, and there are such strong economic factors for why we want to deliver all of our television programming over the internet on there. It might be a bumpy road, but I think that it's a foregone conclusion that there will be eventually broad bandwidth of high enough quality to stream whatever you want over the displays there. But yeah, that's going to be something that's going to be lumpy, nationality and locality dependent on how it goes. It's the old saying from Gibson is the future's already here, it's just not evenly distributed, and that's absolutely true with all of this. There are plenty of places where you've got all the bandwidth you could possibly want. It's just a matter of deployment everywhere.
Yeah, so you think that this transition to 4G and charged bandwidth is a transient? Because if Verizon's going away from high speed and now charging for it by the gig.
Yeah, and they have... they are probably being rational economic actors acting in their self-interest on being able to extract the most money from given markets. They're doing what you would expect. I do believe that they will, I'm a believer in free markets. I believe they will be challenged. Certainly telcos are not the freest of markets and cable companies much less so. But I will take it as an article of faith that the possibility of greater bandwidth that is technically feasible, will not be stifled by one company's business practices. Again, I wouldn't bet on when it's going to happen on there, but I have almost complete faith that in the midterm that it's not going to be a problem. You might feel near-term pain. All right. Anybody else? Are we done? All right. Thank you, everyone. Oh, you want one more?
One more. All right, Mr. Carmack, I've played your games for the last 2 decades, obviously, made a huge impact on many of our lives. As a pioneer in the graphics industry, given the rate of progression of technological advancements, is the end game, like id Tech 10 extrapolating out, is the end game photorealistic graphics? Do you think we'll see that within our lifetime? If not, what are the limitations?
So something that I would like to see done would be if you take, everybody knows game trailers and cinematics and cutscenes, they look really cool. When you go and you ask Blur to do a cutscene for you, it comes back and it looks wicked awesome on there. It would be interesting to go ahead and have somebody just play an existing game. You just stop by while your kids are playing some game, record exactly what's going on in there, and then say, okay, Blur, this is the gameplay, these are the characters, here's what's going on. Give me your most badass clip that you can make with these exact same elements. And we could say that is our end goal, that is the most that we could do with essentially infinite graphics power. We could answer that question now if we wanted to. It would be an interesting exercise to take there and really see how much of the quality that we get in awesome trailers with all the perfect musical scoring and the dramatic directorial eye to things, how much of that is graphical quality versus these other things on there. And my current bet is that, yes, it will look much better, but I don't think that it's something that fundamentally changes the way you look at and interact with games, even giving it infinite graphics power there, saying it was offline rendered and you're spending an hour per frame coming at it. It'll look cool, it'll look fabulous, but it's still just going to be a game that you're watching on a 2D screen there. It's still, you're watching something that's a movie. It looks like a movie on there, but everybody's moving in squirrely game time ways rather than something that's scripted frame by frame for directorial and emotional content like a movie is. So I think that we are closer. I think that we're actually pretty close on there, where in many ways what we deliver with games is already better than what you have in a lot of mediums like cartoons, anime, different things like that, our graphics fidelity surpasses a lot of things that are still viable and valid for these other reasons that are not the content, that are not rendering related on there. And even if we went all the way to the very best, and clearly in the movies they're doing photoreal. People can't tell for the most part now when you're doing computer-generated imagery versus live. So we have achieved photorealism in rendering. We can do that whenever we want to pay the money for it. We can project what that would look like if you were playing a game always like it. It would be great, but it's still going to be the game's pretty much as we're playing. I think that the I/O devices are more important. I think that there will be larger impacts on people by changing the way you interact with them rather than raising the bar 10 more notches on the visual fidelity. We're still going to work that way, though. That just comes as a given. We press on that way, using up everything that we've got available to us. But if it comes down to a place where I have a choice between taking advantage of something that really changes things versus carrying on the existing path, I think there are more fruitful directions kind of looking at other things. And the VR stuff has me more excited than I have been about graphics in years.
Thank you.
All right, thank you all.